Hi, everyone. Welcome to the MCT West African Bootcamp Day 2. Um, I want to officially welcome you guys to the second day of the bootcamp. The bootcamp started yesterday, and I'm pretty sure we've been able to learn a lot from the sessions, from the many sessions that we had yesterday. And I want to believe that you are also going to learn a lot in these many sessions that we are also going to have today. So, the West Africa Bootcamp is a yearly conference aimed at bringing various user groups, various tech communities across West Africa, bringing them together to network, to discuss, to talk about emerging technologies, what is new in the technology space, um, what do you think we can do, and many more discussions around technology. So, uh, I want to officially thank our sponsors, Microsoft, the Brand Consults, Covenant Technologies, Textilers, Wisely. These are our amazing sponsors. I want to officially thank you guys. Thank you for supporting the community. Thank you for doing this with us. So, before I move on, I would like to introduce myself. My name is Goodness. I am a program manager. I am a community person. I am a developer relations manager. I like to talk to people. I like to bring people together. I like to manage programs. I like to conduct events. I like to do what I am doing now, hosting events. Um, I'm very passionate about upskilling people around me, and I currently do this with the Microsoft community, Microsoft student community. Um, yeah, that's pretty much about me. So, in today's session, we have a lot. In today's session, yeah, we have a lot of tracks. We have a lot of topics centered around data, artificial intelligence, and Internet of Things. By 10:40, we'll be having a roundtable discussion. Uh, and that roundtable discussion is to be led by Mike Edera and Frank Odom. I would go ahead and add them to the stream.
Hello, good morning, everyone, or good day from wherever you are. My name is Michael Dera. I'm a software developer based in Zimbabwe, but at the moment I'm broadcasting from Cape Town. So I'm glad to be here and to be moderating the conversation around building the net community in Africa. So now I'm just going to have all the speakers join me, and we'll do some introductions, and then we'll get right into the discussion. Hi, Damien.
Hello, Mike. Can you get me?
Hi, how are you doing? So I think we're going to start with introductions all around. So, okay, let me just wait for everyone to be inside the conversation. Then we just start with the introductions. Okay, you can go ahead, Damien.
Hello.
Hi. Yes.
Okay.
Yes, you can get in view.
Sorry, I had a little issue with my camera. So my name is Damien Bloomer. I'm from Cameroon. I am a software developer and a Microsoft MVP. And I'm glad to be here. Thank you for having me.
Thanks, Damien. I think we can go on to Vincent.
Hello, everyone. Vincent here. I am a software engineer, reverse engineer, security professional, also Microsoft MVP. I am from Nigeria. I work out of Lagos, Nigeria. Thank you for having me.
That's great. Thank you, Vincent. Next, we'll have Laurent.
Hello.
Hi.
So my name is Laurent. I'm a software developer from Togo. I'm broadcasting right now from France. where I continue my studies. So
Okay.
I'm a Microsoft MVP also. I'm also the organizer of Lome.net meetup group. So that is it.
That's great. Thank you.
Thank you too.
Next, Frank.
Okay, so I'm Frank Odum. I'm a software consultant, and I'm also an organizer for Accra.net. And yeah, so I'm usually more heavy into community activities also as well. Yeah, so that's a bit about me.
Okay, thank you, Frank. Last but not least, Dara, could you introduce
Hi.
yourself?
Hello, everyone. I'm Dara, a DevOps engineer, a software developer, and a streamer. I am a Nigerian based out of London, but I love engaging with everyone from all around the globe, especially in Africa, because that is where I come from and that is where I like to improve.
That's great. That's awesome. So I think we're just going to get into it. I'm not sure. I'll just ask for all the panelists to be added. Then we can just get into it. So to sort of like build context around the event, I think we're going to first have a conversation about where the .NET community has been, where we started, and where we are right now, and where we are hoping to go. So I'm going to ask the panelists what's been happening with the communities around where they're from, and the milestones that they've achieved so far, and where they are hoping that will go in the future. So I think, again, we can just go clockwise. So I'm just going to pick on you, Frank, to start by telling us, or maybe perhaps you can give us an overview of what where the community is right now in Africa as a whole.
Okay, I'll just say that right now the community is at least at a better place, because before then we didn't have a lot of like meetups around the other regions, but it looks like now we have a lot of meetups springing up. The only thing I see is the communities are not as vibrant as they should be. So even though we have the communities registered on Meetup and they are organizers for the various countries, we are not actually having as much events as we should. So I mean, there's a lot of work for us to do, to keep promoting the technology and to get people into it. So for now, what I'll say is it's a good place now as compared to before, but there's a lot of work to do.
Okay, yeah. Would everyone say that that's the same situation with the communities? There could be more that could be done. Yeah, I see you nodding, Lauren. Maybe you can comment on the same topic. Where do you feel like the community is right now, and there's a comparison to where we've been in the past? You're on mute.
Yeah, I think it is the same situation in Togo. So when I create the .NET meetup group, I organize the event together with Frank, with Dora, to get more audience. So I think we should organize more events across the country or the West Africa to get more audience. Why not in-person event? Yeah.
Yeah, and Vincent, I'd like to hear what you think about the community in Nigeria. Are you sort of like in the same space where you'd say that the community is growing, but you could be doing more?
Yes, I definitely agree that the community is growing. So we started a WhatsApp group for the community, next 1 million.net. And the idea then was to get 1 million people into the .NET space. And some of the mistakes that we made was that we did not put a timeline for our targets and all of that. But between 2017 and now, we have definitely gotten nothing more than 300, 400 people into the space. And these people don't come from other technologies. So this is not a situation of someone switching from a different stack to .NET. This is a situation of someone wanting to get started in tech and deciding to start with the .NET stack. So that is definitely a good thing. I think that we need regional level events where West Africa is coming together to organize events. I think these events need more visibility. So we need to do more in promotion to get people to know that we are doing something. If we can even have in-person events that are sponsored. So you see things like Node.js conferences where people are flying into the country for it. So we need to invest in marketing where we can have companies that these things are in their interest, like a Microsoft, or sponsor these events. So yeah, those are some of the ways I think we can definitely improve the growth. But yeah, we are improving.
That's great. So you spoke a bit about visibility and we need more visibility. So I'm going to pick on Dara because I know Dara is involved in a lot of streaming and you speak to a lot of people with regards to .NET. What do you think what's the outlook on that? Is that also growing and what more can be done? How can the community, especially particularly those who are not actively streaming or doing advocacy, support the growth of .NET?
Well, for me, I think majorly, I think boiling down also from what Frank said, even when we didn't have so many communities, we're actually doing way more than we're doing right now. Like we'll have meetups like every 2 weeks, like all worst case every month. And there are only a few streamers that actually do .NET from Nigeria. I could literally pick me and Sam and a few other people that actually do that. So people who teach this stuff, I can bet you have good internet. You have internet to download FIFA, you have internet to download PES and play this stuff. And some of us are in better places now. If it's only maybe if you can stream, record the stuff and just put it online to just reach more people. That is what I say. Like right now, I'm so busy. I need to schedule time to chat with my family. Like literally. So I know everybody's busy. We grow up, Muslims catch up with us. But also, I think it also boils down to the fact that the kind of people who bring up after us should take after us. Like if I'm not streaming, someone I've mentored should be able to stream or record videos and push it out. And because we grow older, I think majorly the gap here is most of us grow and sort of don't bring up other people to grow into our place when we grow out of that place. Like now, I still don't expect I'll be teaching fundamental C# on my videos. I should be teaching more advanced stuff, but there are not enough people doing that. Yes, there are a lot of videos online, I must say, but how relatable are those videos to our examples? Those are the kind of things we really want to see from every day. And that's what visibility. It takes consistency to be visible, to be honest. You don't post one video in 6 months and expect to be visible online. For example, on YouTube, I'm talking from my YouTube experience now. You post like every week, every 2 weeks. The algorithm starts knowing you're there and starts suggesting your videos to people. People start viewing from time to time. If it's a meetup you're doing also, you tweet it this day, tweet it tomorrow. It comes to the faces of people frequently, and that is how the community literally grows. But now we just say, people are not watching, people are not tweeting, people are not attending. One thing I say is when you keep at it, the universe just has a way of coming to gather back behind that consistency to ensure that whatever you're doing is visible to the rest of the world. When you start, might be as little. Some of my videos that has most views now, they are videos I've made from way back. Not even my current videos. But because I started posted newer ones, the algorithm brought out older ones for people to actually watch, and that they learn from, and then they can watch other videos. And the moment they grow onto that also, they're expecting more. So we expect someone else to pick up. And what I say is there's enough space for everyone to actually do stuff. Me, Frank, Lawrence, Damien, we can be doing literally the same thing online. Our audiences are different. We have different ways of reaching people. One thing someone from Ghana might not be able to relate with, Frank will make a good example of it, and that person will relate with it and be able to learn. What an example Damien would make might not sit well with my audiences, and I would make it and sit well with the audiences. So we can literally be doing the same thing, and then everybody learns from it in their own way. And one reason I actually started making videos, for example, is when I learned from this, pardon me, so these Oyibo people, I probably understood the examples, but if I take it to a village in Lagos or Ibadan, they wouldn't understand Fuba, all those examples these people give. I need to explain it in terms of what they understand. And step by step, we start doing that little by little, reaching out to these little places, make the video small for them, put it on a flash drive for them. They transmit it like we used to do back when we started learning how to code. Put the videos on a flash drive and store it in one hard drive under our bed. We can replicate that for other places also, and then they start the interest, they bring it up to other people, and then we just reach enough people. Yeah, I think I've talked so much now.
Okay, what you said will feed into the next question, but I want Damien to also comment on where he thinks the community is and where we've been.
So I think like Vincent and to join what Vincent said, like we are not really, the community is not really, people are not really into it. Like you have few people doing the net, and most of the people coming into the net from our communities are people who are new into it, like what he said. People that are new into it, not old people, not former devs like 10 years of experience leaving their old tech to switch to the net. And it is something very meaningful. It's something very to take into consideration because back in our communities, you can see. I think it's like that because most of the people in our communities were used to the Microsoft of back then. Microsoft like closed source, commercial, all of that, licenses. You need to buy licenses to have the best software, nothing open source and all of that. And that is why, back in our communities in Africa, let's be right, in Cameroon, for example, where I come from, people will not like, when you want to launch your startup, back then, now Microsoft is free open source and all of that. Back then, people will dive to Java and like that open source stuff. And that's what they used to do. And they still have that mentality. They are not yet, the information that Microsoft has switched to an open source ecosystem has not yet diffused very well, and that is why guys are not really, old devs are not really enthusiastic about getting into the Microsoft community, and it shows. And really, but now things are moving, and we are really trying to catch up, and we are working on it. And I really hope things will go faster.
Okay, that's great. So we've sort of like established where the communities are. I know there are a lot of challenges that we have in Africa. We are not as mature as some of the other communities, and I see some of the work that can be done in that regard. Are there any unique challenges and opportunities that you think are there that we should take advantage of as a community? Because one of the advantages of being at this early stage of growing the .NET community in Africa is that we can do some things right the first time. So I want to put it back onto you guys to tell me if what are the unique opportunities that we have and the unique challenges that we have is the African community. I'll start with Frank, and I'm going to ask us to be brief because we are running out of time. So yeah.
Okay, so yes, so we do have some challenges definitely in our region because when the COVID hit, we couldn't have like in-person meetings, and we had to resort to virtual, right? And one of the problems with virtual is over here we have problems with internet in terms of the cost of internet is expensive, etc. So you have anytime I remember I organized a C# bootcamp virtually, and you realize that people are interested, but the ability to stay online to actually go through the whole program was a problem. So Sam and I started even thinking about how we could probably refund people's data, back to them after they join the course. So in Ghana, usually you will need probably about 5 or 10 CDs, like to probably be on a 1 hour stream. So we're thinking, okay, if we have 20 people joining a day, at the end of the day, we refund, the data back to you, just to encourage people to be on the streams. But I would like to just commend the Donut Foundation, because during this period, they actually created a virtual meetup that allowed us to get a lot of broadcasts. So if you were last year somewhere, I think this year, early this year also, we had some events with people like Scott and Matt and Maria, and that was broadcasted through the .NET Foundation virtual stream, and that gave us a lot of publicity. So in terms of challenges, I see it's more of an internet thing, and because we are now virtual, but hopefully once COVID is now becoming a bit stable and friendly, we can resume back to in-person meetings just to surpass that challenge.
Yeah, and do the rest of the panelists share the same sentiments? I'm just going to ask anyone
Yeah,
who has feedback on that or comments to
yeah,
say it out.
yeah. I feel like what Frank is saying is right, and it's really a. I like the idea he brought of funding back of refunding back the cost of internet, and it's really smart, and it really encourages, and also to reach back to give a point that can help us like improve the our community and improve the use of Microsoft in Africa, of Microsoft Tech community in Africa and all that. Something important is like we had these meetups that we've been organizing, and as Frank mentioned, one of the meetups we had Scott Hensel, I mean Scott Hunter, yeah, he came and he presented us Microsoft .NET 5. I think it was last year, and in that conference, in that live event, he talked about something. He said like 40% of the new developers who are getting into .NET are students. Like they are newbies who have never done anything. Like maybe they did something back in school, but they mostly have no working experience, and all of that. And it is something that I also noticed back in my community, and also Vincent highlighted that. He said every guy that he could get into the net were like new guys, were newbies, and it is something we should capitalize on. It's something that we should put our efforts on, because as you can see, students that come into the net, they have what they get to see is the Microsoft of now, the .NET of now, open source, free, and with awesome stuff, cutting bleeding edge technology and all of that, with Azure and all of that. And
Yeah, so I'm
there,
going to pose a question on a point that you raised there. You spoke about everyone who's coming into .NET being new. One of the challenges personally that I noticed is we need to do more work when it comes to making .NET a comfortable place for everyone to come in. For example, and I'm going to pose the question back to you because you're in Cameroon. I know there's Francophone Cameroon, right?
yeah,
And Anglo Cameroon. How do you handle the situation where you want more people who are from Francophone Cameroon getting into .NET? Another thing is like right now we need more women in .NET. Like in this panel right now, they are only guys. So I want to pose that questions to all the panelists, and and sort of like hear your comments on how we can sort of like make it a comfortable environment to come into and more inclusive.
so to answer, to make it more inclusive, I guess that's your question, making it more inclusive. To
Yes.
make it more inclusive, we just have to target those people that are, we have to target the minorities. What we do in Cameroon, back there in Cameroon, we have the women tech maker. and it's a group. It's an association of girls, of women students, and all of that who are into tech, and they organize events just like what we do, and an initiative we can move to them and collaborate with them to spread our message and evangelize. That's the first thing. And for the French part, the French speaking part of Cameroon, tech is in majority of tech is in English, so they have like no choice than to learn English. And I myself am from the French speaking part, but I studied in the English speaking part. And I do English and I speak English, I speak French, and I have no choice. So we just have to get to them and introduce them
Yeah.
to it. So that's my.
I'm going to quickly pose the same question to Dara and then on to Vincent. And then I'll have another question for you, Laurent, after that. We are almost out of time, so I'll just ask
Okay.
you to do a minute
Yeah.
each.
Okay, being inclusive, I think it's generally something we should definitely look at. Like all the guys here, all of us here, guys. Yeah, even though we have ladies doing stuff, most of them are not out there. We need to push them. Yeah, like literally push them. Because what I realized is the ones that are doing great things, they don't want to come out and speak. We just need to give them that little bit of nudge, of an encouragement. Like, look, you're doing this amazing stuff. There could be someone like you that is just 16 or 15 or 14, waiting to see someone like you doing great stuff. Do you want to see the next you in this time? And this kind of encouragement actually come on. And one thing that we can also do better is actually be in their faces all the time. Like if in their faces, they'll come ask questions and then we can get them involved. I remember some of the people have gotten started to actually be mentors to other people. It's because they saw me doing stuff and be like, okay, I will answer your question, but you have to promise me to give this answer to 5 other people. So
Okay.
if we are actively doing that, as we give them answers, we tell them, go share the news with others, go create that blog post on the answer I gave you. I wouldn't create that blog post. I will ensure that you do that. And then that way, they come out, they become more encouraged, they start doing stuff, and they just get the fire on.
Okay, that's great. Vincent?
Okay, I am going to speak to two things. The first one is about how do we even get more people into .NET. The I think partnerships is a very strong way to go. I think a lot of people coming into technology today, coming to programs like the HNG Fellowship, She Code Africa, and all of that. And we need to get skin. So you see that these programs teach things like Golang, JavaScript, and the rest. And these people teach people, they teach the technologies from people that sponsor them. So practical examples is we need a governing body for the .NET West Africa or .NET Africa. One thing we can do is to elect people that will actually champion these partnerships, meet people like .NET Foundation and say donate to these people. So then we have skin in the game. Because we have donated money to them, they will say, okay, we will teach C#, we will add .NET to one of our tracks. That is a very practical way to get in. The second thing about inclusivity and getting more women into technology, I would say we can just ask the women. It's easy for us to start to say, oh, this is what we should do, or this is what we shouldn't do, or this is why they are here. So we can really just reach out to the women in technology doing .NET and say, we would like to see more women on our panels, and or why are we not seeing them, and just leave them to answer those questions.
Okay, so unfortunately we've run out of time. I had another question about how we can do more is getting together as communities around the region, but time has run out. I hope that we'll have more opportunities to have these discussions in more detail and actually come up with implementations of all that we've spoke about. Thanks for joining us for MCT Bootcamp. I hope you stay for all the other sessions. Thank you guys, and goodbye. I will hand it back over to Goodness now.
Cheers and goodbye, everybody.
That was a very interesting session. A lot is going on in Africa. A lot is going on within the .NET communities, and it is good to know that we as a community we are preaching inclusiveness. We are preaching diversity. I mean, bring people into tech, bring people into the .NET community, bring ladies, balance the equation, bring them, let them learn, sponsor organizations or bodies who are willing to take on these trainings. And it is good to know that as a community, these many more are what we are interested in. Thank you very much, Dara. Thank you, Michael. Thank you, Frank. Thank you, every other person that joined that call. Um, so right now we'll be moving on to the next session. Yeah. So the next session starts by. Sorry. So the next session starts by 11:20, where Paul is going to be taking us on a journey to a modern data warehouse. But before that time, let's enjoy this very short video. Thank you. Thank you very much, and welcome back to the MCT West Africa Bootcamp. This is the Data, AI, and IoT track, and we just finished a roundtable discussion around .NET communities in Africa, and we would be having our next speaker come up now. But before that, I want you to head on to aka.ms/MCTWA evaluation and complete the evaluation evaluation session there and stand a chance to win amazing prizes, including a Microsoft Xbox. Right. So we have a lot of amazing prizes in stock for you. So head on to that link. I would drop it in the chat. Head on to that link and complete the evaluation. Thank you very much. So I would bring Paul right um, on board now. So Paul is a business intelligence architect with over 9 years experience building business solutions. Um, he architects end-to-end automated reporting solutions for enterprises that leverage MS corporate BI stack and Power Platform. So Paul is probably going to talk more about himself and also a topic titled Journey to a Modern Data Warehouse. So I'm gonna bring Paul on the stream now. Over to you, Paul.
Okay, thank you very much. Please, can you confirm if you can hear me?
Yes, loud and clear. I can hear you.
Hello?
I can hear you.
Okay.
Yes.
Thank you very much. Thanks for the warm introduction. My name is Paul Barnabas. It's a privilege to be here on this session, the MCT West Africa Cloud 2021 Bootcamp. My name is Paul Barnabas. Just to give a bit about myself, which my colleague has also said, right? I'm a business intelligence architect. I love the community. I love talking about data, about AI, you know, about data management, business intelligence, Power BI, things around business intelligence and data. These are the things I love to talk about. And beyond that, also, I lead the data management and business intelligence team at an FMCG here in Nigeria. And today I'll be talking about the journey to a modern data warehouse. Okay. So, the idea here is to take us on a journey, is to make us understand exactly where we've started from when we talk about the concept of data warehousing, right? I believe the keyword in the topic is a modern data warehouse. But before we can understand the full grasp of data modern warehouse, I think it's important for us to identify and understand where we are coming from. As you can see, this is a very complex chart, and you are seeing different types of things in here. But just to put it in perspective, right? What we have here is an environment where we are gathering data from different data sources. It could be a CRM, it could be an ERP system, you know, a line of business application, and all of these informations are probably coming into a landing area, right? We have the data quality services, you know, analyzing this data, have the master data management, and all of these informations are evaluated and then sent into an analytical platform service. You know, more of a staging area where will be different schemas, and we also have data mats built, you know, for different functions within the business, right? A star schema is built, you know, that helps with tabular analysis services. You know, a multi-dimensional model also can be built, or a Power Pivot for SharePoint. These are features, these are solutions, technologies that were in the vogue some 10 years ago. These were the order of the day, you know, so, and we see as data moves from being gathered to being cleaned, and the master is created based on them. So we have the master data, we have the transactional data, you know, and this moves to be stored. And then from there, a model is built, which can then be presented. So there's an analysis part of the of the whole process, whereby with the use of SQL Server reporting services, Excel, and then King Power BI, right? Some of this information can be built, can be analyzed, and then with the use of a platform like SharePoint, you can essentially share, this information. So based on enriching all of this data, yeah, we have a concept around here where, some non-relational data, are collected, not properly structured, right? In different formats, and then they are also augmenting this information here coming from a relational data source, right? Looking back also, in the last 5 years, there's been an evolution, so an evolution beyond that scattered format of building a data warehouse, ensuring data goes from the source to your report, simply turning data into insight, right? We've also seen that we have this thing structured. There's been the evolution, and then there's been the realization of self-service, business intelligence, such as Power BI. There's also the corporate BI stack, which is the SSIS, the SSES, right? So we have collaboration available on these platforms. You can also now view your reports on a mobile, device, and then there's the enrichment of predictive analytics. All these are based on a few core concepts where you have a single query model, you do your ETL, you are able to achieve data quality and maintain it. You're also able to have master data management. And all these are based on data coming from different data sources, either a structural or relational data source, like the online transactional processing system, your ERP, your CRM, or line of business application. And it could also be, coming from devices. It can be tweets, it can be IoT devices, it can be crawling information from the web, all different type of devices, and all of this information essentially fall under these three different, one to about five different, categories. So either it's relational, it's not relational with the use of Hadoop. There's an analytical model, maybe with the use of analysis services, streaming data sets, and internal and external data sources, probably by the way of an Excel file, a CSV file. So all of these has been the evolution that has happened in the last 5 years. But beyond all that, how can we essentially appreciate the use of a modern warehouse? Before we go into that, as as a core crux of today's session, I would need to take you also on a journey of identifying or seeing how analytics itself has matured over the years. Because as analytics has matured, this has essentially informed the type of technology that's needed, that has to be used. So as you can see here, we are seeing here on the left-hand side the workload complexity. So before it was just operational data, over time there's been the need for us to start making decisions. And with the use of data science, it has led us into concepts around predictive analytics. So you can see there was a descriptive era, diagnostic and predictive, and then now is prescriptive, such that you can essentially prescribe, you can know before time that you will be having a breakdown. For example, in a car manufacturing company, whereby each machines that are producing some of the parts that makes up these vehicles essentially are the data collected are run through models that help them detect if there's an anomaly, if there's going to be a breakdown. So there's been the need of this. These are business needs, and the complexity of data has essentially facilitated the need for us to evolve. And then we have moved from just basic reporting, to self-service reporting, so you can see all this before was just batch, limited Hadoop, single version of truth. And this had moved on to, okay, now we need to start identifying KPIs, as coding informations, KPIs that are helping us make decisions. Now we can do large Hadoop, combine different things, So looking at the data sophistication also, you can see the trend. It says from what happened, why did it happen, what may happen, what is happening, and what action should we take. And as we move along, there's the exploratory analytics, there's real-time analytics, and there's this real-time predictive modeling and mining. So all these are event-based. So IoT devices that are bringing in data are leveraged with information coming from a line of business application or from a CRM and ERP system. All of these things are mashed together, in a big data lake, and we have ML models, leveraging on this data and churning out insights, churning out information, so predicting that, so if you continue on this trend, you could experience this downtime, so that's what we've been able to, to get out of enriching data or transforming data, so this is, the maturity we've been able to achieve or see in the last 10, 15 years. And, that leads us into essentially understanding how a modern data architecture should look like. So we have real-time processing at the crux, where we have data in motion coming from different types of source systems, from the web, machine logs, text, audios, videos, ERP system, relational, non-relational data, and all of these things within the data warehouse. We are getting insights, business intelligence insights. We have SLE to ensure that, at least 99% uptime. We don't have any downtime in terms of the system supporting this data. Beyond that, also there's data discovery. We have concepts around graph where you can do search. You can search, and then your search will go across the different dimensions of data that you have within that platform and can give you enriching information. And beyond that, also the platform is fast. You can filter very easily. You can do exploratory analysis. You can do online archiving. And beyond all this, essentially you can get, informations on marketing, application insights, business intelligence, and all of these key areas are essentially being factored because it's just more than just I have some set of data and I'm transferring that into a report. It's not just ad hoc reporting now. It's getting insights on the go, real-time insights, transforming data into insights. So that has necessitated the need to build and have a modern data architecture. And this leads me into, the platform itself, Microsoft SQL Server, which has helped, over the years, gathering data, storing data on the on-premises, environment, and then seeing the advantage of the cloud, how we can essentially move data workload, from on-premises to the cloud. So as we said, different types of data sources, structured, unstructured. We have an area of data management where essentially we have the operational, the OLTP, part of the infrastructure, which is an SQL server. We have the data warehousing, we have big data processing, and all these can exist actually on premises. But what are the advantages if we're able to move, some of this infrastructure from our own premises environment to the cloud? So these houses, it's an exact replica of you having an SQL instance, but here there are different offerings. You can leverage on if it's an SQL server, in a VM, an Azure SQL database, and the Azure SQL data warehouse by way of the Azure Synapse. Within Azure Synapse also, you can still do your Azure AD insights. You have your Azure data lake, and looking at data insight itself, you can leverage on all of these informations. And the highlights of today's session, right, is to see how we can essentially look at one single product within Azure that helps us achieve most of these things. Yeah, so beyond all this, there's a layer of security, because as for most organizations, they are bound by different policies. And, this platform, Azure itself, has been certified by all of these providers. And essentially, it gives you a level of assurance that your data is secured, your data is protected, it's not violating any rule, and then you can also leverage on different types of programming language, to essentially consume information or consume data, from these sources. So I think it's high time we actually identify that if we are talking about on-premises and identifying the cloud as an option, for hosting our modern data warehouse, it's important for us to see what are the trade-offs, what are the benefits, what are the advantages, right? So here is a chart telling me that if I want to choose cloud, or if I want to choose a mixture of both on-premises and cloud, what would be the best strategy for me? And then this is just telling us, okay, fine, if you are simply staying on premises, there are a lot of things that are involved, such as buying the infrastructure in terms of renting the workspace, buying the servers, buying the license of the SQL server, paying for the resource, as a database administrator or a data engineer, you're paying for electricity, you're paying for bandwidth. All of these things would be your major cost, and you can see it has a high level of cost. The administration also is higher because you'll have to continue to do backups, maintenance, ensuring that your service is up. If you have any power failure, all of this would have impact on your on your SLA. And as you go along the chart, you see whereby we're having infrastructure as a service, whereby you can still move some of your workloads. So might be different thoughts around a business saying, and I still want to have the control of being able to do my backups, do my optimizations manually. You can actually move your SQL Server workloads into a virtual machine in Azure, and that helps you, achieve a hybrid cloud. So there might be a version of it sitting on premises one day, and then you establish a link between both services, and then you can transport data from your on premises to your cloud. And you can also decide to go full scale, with the leveraging of Azure SQL database or Azure Synapse, for essentially moving all of your data workloads directly into Azure Synapse. So this gives you the availability within a workspace, to be able to do the data ingestion, do data processing, data storage, do insights, so all of these things you can achieve by the time you move your data, from on-premises to the cloud. And I think it's essential for us to also look at what are the ways we can achieve, moving data from on-premises to the cloud. And we can achieve that, through these two ways of migration. So you can make use of the data migration assistant. It's an application that you can install on your system that essentially assess, the source and the destination environment, and see what is compatible and what is not compatible, and then make a recommendation. And then with this, you can essentially move or migrate your data from on-premises to the cloud. Then there's also an offering, a service within Azure called the Azure Database Migration Service. This essentially, provisions a link or provisions a service that helps link up your data source on-prem and the one in the cloud, and then it iteratively, moves your schema, moves your data, and gives you a holistic report, on the process of your migration. And this also opens, the doors to different and multiple data sources, to be essentially ingest and move data, from on-premises to the cloud. Okay, and I think this is taking us into what, the feel and the look of a modern data warehouse looks like. So we've seen, as earlier in this session, looking at a very complex chart, looking at different old system, but here we are looking at a data warehouse, a modern data warehouse that gives me capability to, manage huge data. It gives me capability to manage huge data in terms of big data, right? To manage data from different types of data sources. As you can see, is it a line of business application? Is it from the graph? Is it an image? Is it an IoT device? or probably even other cloud system. You can bring in all of this, data, and then we have different offerings within Azure, right, that can help you ingest, by way of the Azure Data Factory, the SQL Server integration services. You can ensure and utilize these solutions to, extract, so you do your ETL, your extraction, your transformation, and then you are able to load your data into, a data store in Azure, by way of a block storage, an Azure data lake store, an SQL server, sitting in Azure. And beyond all that, I know, as we talked about the enrichment of analytics, you also want to be able to carry out, extract insight, be able to, to enrich your data and, build analytics of that data. And then with the use of, Azure Databricks, Azure HD Insights, Azure Data Lake Analytics, and a whole lot of other tools or technology available in Azure, you can actually prep and train your data, and also go ahead and build models, different types of models within the, the data warehouse, by the way of Azure Synapse Analytics, so and there's Azure Analysis Services, so all of these things you can leverage on, so this is giving you a holistic and enriched data warehouse, whereby within that system, you can achieve extraction of data, storage of data, training and enriching that data, with email capability, building models that can be consumed by different parties. And then you can now have front-end tools, like BI, like Power BI, either within Azure Synapse or standalone, and you are doing reporting, you are doing real-time analytics, and you're also doing advanced analytics. So this is the picture of a modern data warehouse. And beyond this, right, excuse me, beyond this, right, we are looking at Azure Synapse as a focus. Azure Synapse as a focus, so within Azure Synapse, it's a platform that essentially helps you achieve what we've talked about in the architectural form. So with the use of the studio, you can do data integration, you can do data management, you can monitor, the workloads, you can monitor, the processes, you can, also leverage on security inbuilt, within Azure Synapse to ensure that, if it's in terms of role level securities, in terms of, not exposing the data, sensitive data, all of these things you can achieve if it's to apply role level security also in terms of privileges, to users who will be consuming the data. So you can set up for, your data scientist, you can set up for your data engineer, for your BI reporter, all of these things you can profile within Azure Synapse to ensure data is available for the individual, roles. So all these tools are leveraging on SQL, so Azure Synapse SQL, also has its own version of SQL. You can query Parquet files, you can query, an SQL server, so there's also Apache Spark, and there's also the Data Explorer. And all of this data essentially are sitting on a very fantastic technology called the Azure Data Lake Storage. So the current version is the Gen 2. So we had Gen 1, Gen 2 is way faster, more optimized, more efficient, and holistically within that same platform, you can also, make use of Azure Purview, which is a data catalog, an enriching platform that you can essentially see the life cycle of your data objects across different data sources, or leverage on, Azure machine learning, to enrich your data. And then also Power BI, for reporting and analytics. So all these are essentially available. All these are essentially, present within Azure Synapse. So this being a core technology solution that is based on the modern data warehouse, so just to see some of the features, the advantages, of this solution. Its intelligence is way faster, it's more efficient. You can achieve insights and prediction, way, 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 way faster than the traditional way of doing some of these things, or the separated or the less integrated way of achieving this. There's also trust, so you can get your own keys. You can there's even a solution called bring your own key. So with this you can ensure that your data, even though it's resident in the cloud, is essentially protected by you, right? And beyond that, there are different types of compliance standards available that is essentially protecting your data up there in the cloud. And this also helps you to grow your business. So probably you had some set of servers that were going out of life in a couple of years. You can move your workload, your data workload, to Azure, and this helps you essentially grow your business because you can scale up and scale down. And this leads into the portion of me talking about the flexibility, whereby you can scale up, you can scale down your resources. You can essentially leverage on a solution that is always up to date. So in terms of patch ups, they are done real time. They are done as fast as possible. As bugs are detected, they are creating patches for them to ensure, that they are up to date. And this also helps you at any time if you want to do hybrid, if you want to stick to cloud, if you want to even, go back to on-premises. All of this flexibility are essentially available. And then also you can leverage on all open source, innovations like Spark, like Python, like Hadoop, like R, so all of these things by way of technology or by way of language, you can essentially, leverage on this. And I think the question is for somebody who has understood this, who has looked through all this, and is saying, okay, fine, what are the questions? What are the things? How do I ensure I'm essentially ready, to migrate? What are the things I need to know? What are the questions I need to ask? And that leads us into the sets of questions I have listed here. And I'm just going to take them one by one and then we begin to talk about them. So you begin to ask yourself, does our environment handle diverse data sources and a variety of subject areas? So if you have an environment that probably some of your data sources is existing in a way, is on a machine line, for example the manufacturing line, or you have some data in the cloud by way of an IoT infrastructure or social media information. If you have environments where your data are coming from and they are disparate, yes, you can leverage on a modern data warehouse by the way of Azure Synapse, and these are the things that can help you be able to integrate all of these solutions or these data sources together. You can achieve these things. So yes, if you have if that is one of the challenges you have, yes, then this can essentially solve it. So can we handle excessive volume of data? Social sensors I've listed. Yes, yes, yes. So if your questions are, yes, we need to be able to handle all of these things, then Azure Synapse is the right solution for you. Can we support real-time or near real-time analytics to provide instantaneous insights? If these are your requirements, then I tell you, yes, it's possible. Just as we saw in the data architecture, and then as we saw also in the last slide, we can see just all within one platform. As you are ingesting data, as you are enriching them, you are adding ML languages, ML models around these things, also building different models. You can be getting real-time insights that helps you make
Michael,
decisions on your
sorry
own.
to cut you. Sorry to cut in. But we
Yes.
are far behind time now. Thank you.
Okay. Thank you very much. So this list of questions, right, essentially can be checked one by one. And these, as you go through them, you'd see that Azure Synapse essentially helps you achieve, your goal of essentially ensuring that from data ingestion to storage of data, to enrichment of data, to modeling of data, to data analytics and data insights, all of these are covered within the scope. Thank you very much for having me I think this is the end of the slide, and this is the end of my presentation. I'm open to questions, so if there are questions, please go ahead and ask them. Thank you very much.
Thank you very much, Paul. That was a very nice session and insightful session, by the way. Thank you very much. There are questions. Let me check the screen to see if there are questions. Okay, I do not think we have questions. So if questions come in after now, then we'll definitely get them to you. Thank you very much, Paul, and do have an
Thank you very
amazing day.
much.
Bye.
Right.
So that was a very quick one, a very nice one from Paul. We'll be going straight into our next break, and after that, we'll be having a session on how data can transform Africa, starting with secondary schools. Before that time, we would quickly go on a short break. Thank you. Hi everyone. Um, Welcome back from that very short break. There was a little mix-up with the previous videos, but yeah, we are back and we're here. So the next session we're having now is gonna be with Mercy George Ibafe. I'm very sorry, but I'm pretty sure she's going to do the corrections when she come up here. So Mercy is the vice president, brand marketing and communication at Lenton. She's an educator, an agile and data enthusiast, a trainer, mentor, a coach, and facilitator. Um, she has about 20 years of work experience and 5 years in the information technology sector with an outstanding track record. So Messi is also going to do a little bit of introduction before she gets right into our session, but she's going to be taking us through how data can transfer Africa, starting with secondary school students. So I'm going to add Mercy up to the stream. Hi, Mercy.
Hi, how are you doing?
I'm doing very well. And you?
Fantastic. Thank you so much for having me.
Thank
I
you.
should have Maxwell on the call. Are they in the back studio?
Yes, Maxwell is here. Okay.
Okay, you have him.
Yeah.
What about Ichiosa? Is he there?
Okay. Yes. So it's just might want to enable our video. Okay. Okay.
Thank you
Okay.
so much.
All right.
So today
I
is
think
a
you should
final competition.
do the correction about the name. Apologies there.
It's all right. It's okay. So today is just more of a conversation of the relevance and the importance of data, which cannot be overemphasized. Um, so I'm going to be starting with a little story. How I went to school. I went to a public school. Okay, as we all know, many of us got the opportunity of going either to private or public school. My parents weren't wealthy, so my parents weren't wealthy. So as a result, I was I had to settle for what they could afford, and which was the public school. So some of the things I remember was we crammed a lot. And not because when you're done with cramming, you remember what you have been taught. Number one, we go, when they ask you to times five, I'm sure you go in your head. You don't say to the teacher, two times one, two times two, four, two times three, six, two times four, eight, then two times, you know, tell the teacher, two times five is 10. So Maxwell, my name is Mercy George Basse. I'm a digital strategist. I'm Microsoft certified trainer on the Power Platform, and I am equally the founder of Lentor, or the vice president, brand, marketing, and communication. So I'll let Maxwell go and introduce himself, and I'll let Etiosa equally introduce himself as well.
Hi everyone, and good afternoon. I'm Maxwell Echo. I'm a Microsoft certified data analyst and also a Microsoft certified trainer as well. So I I have a passion for data and see and trying to see how much more we can do with data and to really see how data is actually transforming the world as well. So I'm also you want to call me an agilist as well. I love the non-leadership, the non-title based way of working that fosters collaboration and engenders innovation as well. So my passion for data as well as artificial intelligence as well. So that's just a brief about me. So I want to thank you for having me on set. Yeah.
Thank you so much. Etiosa, you want to do us the honors of getting to know you?
Okay, my name is Etio Saudia. I'm a professional Scrum Master, a micro certified trainer, micro certified data analyst, and a data enthusiast. I've been in the IT space for like 11 years plus. That's it. That's just all about me. Thank you.
Now, quickly, let's talk about us going to school. What's memory of going to school? And how do you think data could have been a game changer if you had the being the last person that spoke? Hey, Chelsea, are you there? I think it's my screen is frozen. Maxwell.
Yeah. I'm right here. Yeah.
Hello?
Okay. Yeah,
Yeah.
I'm right here. Can you hear me?
Yes, I can. Did you hear the question?
Was that question to go for me or?
To both
Yes,
of you.
you have to go first. Go
Okay.
first. Go first.
Okay, that's no problem. So just repeat the question for more context.
The question is, tell us about your going to school experience, number one. How do you think what you know about data, how could it have changed your life or the trajectory of your career path?
Okay. Yeah. One of the things we know is all about insightful data. Is all about for trying to make data-driven decisions, and basically most of the decisions we make are really not actually data-driven. For example, maybe being in secondary school, for example, now you may decide to maybe choose one area of interest, maybe based on peer influences, not really based on strength as well. So, and in the end, you may find out that you may just find yourself rigmaroling in the sense of dabbling into so many things, just trying to find your hands on. But I assuming if there were a process like maybe a simulation process in check for you to like maybe try your hands on something, you definitely will want to know what your strengths are. So basically, I think that's one of the ways it would have really helped to really revolutionize maybe the career path one would have actually taken. But though for me, I didn't really have that much as a challenge. It was just like coincidentally things I just felt okay. But the decision I made, okay, I wanted to go in a particular direction was just maybe based on some interest, and in the end I just like felt to I just followed on with that. But definitely in our situation it may not really work like that for everyone. But coming in context that data could help us make effective decisions is actually bringing that to bear is something that could really help out for making people to actually find their path early in life. So I think that's really something worth considering. Yeah.
Thank you so much, Maxwell. And Etiosa.
Yeah, I believe data could have, if I had data during my time in terms of Power BI, data analytics, you understand, it would have helped decide what career paths I would have gone to. You understand? Whether it's medicine, whether it's engineering, whether it's law. I will tell a funny story. My junior brother, and this could have actually helped him when he was in year one. He was both in the medicine class and the engineering class. Now, if he had data to know where his skill set was, you understand, he would have been able to choose effectively whether he should be a medical doctor or become an engineer. But unfortunately, he just chose on his own, and to this date, he's not really sure whether he would have fared better as a medical doctor as opposed to being an engineer. So if he had data at that point, I'm using him as a case study now. if he had data to test his skill set, he would have been able to decide effectively whether he should be a medical doctor or he should be an engineer. I believe that data could have helped in that area. And I also speak for myself. I believe that data could have also helped me to know whether, okay, I could have been in the artistic field, whether I should have been in the science field, or whether I should have been in the economics or statistical field. That's where data could have come in. It could have tested my skill set and know where I am good at. So I think that's where data could have helped. Thank you.
So according to a report that I saw on United Nations site, it said globally 2/3 of children, that means 68%, which makes up 262 million of children out of 387 million of children are going to school, meaning that at primary 6, they will not achieve maximum proficiency because of the kind of program or the courses that they learn. It's more of the teacher teaching us them, not them using their creative ability, which is one of the things that Etiosa has spoken to. Number one, Nigeria, I know for a fact, many of us went to university. Our parents wanted us to go to school, not because we had a clear-cut path, or we went to school due to peer pressure, or thank God for JAM. I will now jam you out of your cutoff mark. Some of you will go and learn, or some people will learn about Yoruba friends, and they come out, they are lost, they don't know what to do with it. So that speaks clearly to that report of the United Nations. So, as you have said, Etiosa, do you want to dig in deep? How data is important today. On Google, it says data is the new oil. It's the new oil. So it's not about the crude oil that we are adversing. It's the person that understands the ability to interpret data, to make sense of data, to be able to see a data and now say, if we go this way, according to what data has informed us, we will change the game. So I'd like Maxwell now to speak to the point that there are education systems. There are education systems in Nigeria. How do you think data can help a lot of the secondary school students today make a lot of difference? Maxwell.
Yeah. Okay. Yes, there are lots of aspects. There are lots of aspects to this. Firstly, you look at data from the administrative and legislative point. You also look at data with whom do we collaborate with in terms of driving collaboration, and we also look at it from the aspect of who are those we are trying to get fact findings from. Now, I've just brought in three concepts. I brought in the legislative point. I've brought in those who will need data for collaboration, and I brought in also those who we want to find some facts on another. So now there are two things. Now, looking at it from secondary school perspective, now we may be looking at how we're trying to improve the way students learn. That's one of them. Number two, you will also be looking at it. How are we trying to improve educators' performance? That's something. Then the third point will be how uh, do the legislature or the administrative arm come to bear in trying to really help out. Now, the administrative arm could include different initiatives like let's say global partnerships and all that. Now, for example, I want us to begin to have a reorientation. So it's not all about somebody coming to school and you're telling the person that the person is dull and all that, and the person does not fit in. Have we looked at what is our standard for assessment? Most of our standards of assessment are not really based on collaborative engagement between instructors. It's all about sometimes you just going to borrow something that have existed maybe somewhere else, and just trying to implement it here, not knowing if it's actually implementable in your environment or actually scalable in your environment. Just to give a side note, I remember being in university and I was still doing 8086 processors at the time. So I was wondering, okay, why am I doing 8086 processors when there were like lots of processors invoked at the time? So that's the first thing. So we must look away from the perspective of trying to collect data for strategic engagement alongside educators. They'll look at, okay, what are the ways we can help to improve learning? And what are the ways, what is going to be the standard for us to measure students' performance? That's something. What are the, what key core subjects do we need to actually integrate? I think those are things that we really need to look at. Now, secondly, we look at the next thing will be, how can we actually improve? How can we improve the student? So it's beyond if someone maybe someone is having a struggle area, the question is, how can you assess that assess that struggle area and being able to assess it effectively? So you're looking at the students, for example. Now, in order to actually try to maybe get at some of these struggle areas from the students, sometimes that's why things like because looking at a school collects lots of data from students' report and all that. So looking at from students' report, by trying to analyze students' report, we can look at the struggle areas. So it's all about, first, because we believe that everybody has the capacity to learn something. It's all about how does a person approach the learning process. So that's a new perspective.
Thank you. Because of time, we need to move quickly, like the speed of light. There's a question in the chat from Sandra. Sorry?
Before you move on, there's a question in the chat.
Yes, I was about to pick that up from Sandra.
Yes.
Yes. So Sandra is asking, Sandra Oji, which is going to speak to what Etiosa was saying. It says, can data help assessing which discipline suits a student? If yes, what type of data? I have been listening, but I still can't get how data can help students choose a discipline. So, Etiosa, let me just quickly add to this, but I'd like you to say something with regards to this, because you were talking about your brother must have been as a result of the conversation. Do you want to go now?
Yeah, I'm set. Now, with data, for instance, let's go practical. Let's make everything practical. Let's based on what I'm going to say now. Assuming, because at that time, I remember before we got computers and internet in Nigeria, that should have been late 80s, 90s. No, maybe, year 2000 was when we got computers. So now we didn't have computers when we were in secondary school, even up to year 1, 2, 3, my year 1, 2, 3, no computer. So let's assume that in secondary school, records were digitized. When you have your report card, you're not just getting it physically, but the school also has it digital, which some schools have now. When we're talking about back then, let's say they have them digitized. Then they know those students who are doing well in maths, physics, chemistry. Then let's add biology. They know those people who are doing well. Those people who consistently do well from JS1 to 3, SS1 to 2, by the time they get to SS3, what people do now is that what schools usually do is that they move those students to A class. Those are the science students. So their career path for them, they could be doctors, they could be engineers. That is one side. Now, those who are not doing well, but they are doing well in economics, They are doing well in agri science. They are doing well in some other arts, like they're doing well in fine arts. We had fine arts when we were in secondary school. They will move those ones to D class or C class. But let's say we move them to C class. Those ones, when they want to, their career path could be law, because economics, law, they go hand in hand. Then their career path they could also be economics. They could also enter the social science departments. Now, these are practical ways in which you could use data. You now figure out those who are doing well in the science subjects. You peel them out, because somebody who is good in maths can be a good engineer, because in engineering you do lots of maths. Somebody who is very, very good in biology, that person is on the line to be a very good medical doctor. These are practical ways in which data, and then if you have this data digitized, you already know the students. In fact, data can also help you track out if a student is likely to drop. When you say a student is dropping, it's always failing class, coming last. Of course, that's already demoralizing, and the person with data, you can track whether that person will drop out or not. So, but these are just the practical ways in which you can demonstrate whether data can move from one discipline to the other. That's it.
So let me take it up a notch, because I think we have like 9 minutes. So most of what our teachers have done, they've just used IQ. Not because they've leveraged on the empiricism of the data that is in front of them, or because you're an A student, you're doing so well. It means that automatically you're a science student. Does it mean that you really love the act of science? I'll say this much. In Finland today, why their education system is one of the best in the world is because of the freedom for the students to pick any subject and learn. They are not guided by curriculum. They are not guided by modus operandi that they need to follow end to end. It's a free learning opportunity. So it breeds creativity, number one. It gets them data. And that same approach is applied to their prison system. Their prison system, you don't have inmates that is a recurring crime committer now coming back into cell. So take for Nigerian, for instance, if I have what I know today, if I'm opportune to know what I know today back in secondary school at the university level, how it is important. Number one, I will get international job opportunities. Number two, I would have been much ready for the job market, not doing it at almost 50 years old and trying to make a difference. So I hope, Sandra, that answers your question. I'd like to see your comments in the chat if that responds to that. But the goal is, data is important. From beginning, exposing a child to telling them, listen, what you have in your hands, the arrangement with your family, how you come to school, your pattern of education. This is the reason why you're dipping. This is the reason why you will scale. This is the reason why the data will continue to help you make information. But the teachers have knowledge. Oh, this child is very brilliant, so therefore is an A student. I've seen doctors that were A students that are now fashion designers because it was a mismatch of placement. And they did not leverage data to have that interaction with the learner. So data is critical. Starting to train children how to harvest data, how to make a difference, make decisions is critical. Okay, I see her respond in the chat. And she goes, I understand now. In my school days, we have such data through manual. Exactly. It's paper, documented. We have through manual. And at the end of the day, we also have guidance and counselor tutors who advise the students on what career path. But they are not necessarily asking the students, do you want to learn this? Are you interested in doing this? So they make the decision for the learners. So Maxwell, I think we'll do one more round and we'll round up because we have like another 5 minutes to round up.
Okay.
Maxwell, what do you?
Yeah, okay. Yes. Just to corroborate with what you said, absolutely. Me, I'm looking at a perspective where you are no longer in a data driven decision initiative. You are no longer trying to make decisions for someone. You're just like you said, it's not a must that someone is maybe someone seems to be good at a particular subject that will mean that eventually the person's strength areas or focus areas is that. No, that's not what we're talking about. But trying to get data from an intrinsic level. For example, a student is failing. Why is the student not failing? Why is the student failing?
Exactly.
It's not about saying that the student is dull. So it's a different perspective now. So in that case, you now look at all some people who are like data evangelists now will now try to work with these educators through some global partnership so as to expose them on some of these data they are collecting and how they can effectively leverage on this data to actually make insightful decisions. That's the goal. That's the focus. So, and with that, it will be about a difference. You will see lots of people being encouraged to take up schooling, finding their own path, finding their own direction. So that's actually the way to go. That's my own perspective to that. Yeah.
Thank you so much, Maxwell. It's your turn. I'd love to hear your contribution as well.
I have nothing much to add, just to reiterate one last point that more often than not, there is always a pattern. Now, it's not all the time, but let's say like 70% of the time, if someone is doing well, I've seen cases where some people force themselves. They were in C class, they were in arts class, they still went to university and did medicine. They ended up doing receipt till they were now managed to become doctors. Because in the medical profession, there's nothing like everybody's passed. Now, more often than not, this pattern works, but I'm not saying that it is a rule. 70% of the time, those people who are doing well in their science subject, as long as they're not forced into it, are more likely to go into the science inclined fields. That was just my point. Thank you.
Thank you so much, Etiosa. On this note, I know we have 2 minutes. So this is me calling out educators, me calling out principals, me calling out one of you, everyone, mommies, daddies, before you make a decision for your child. Oh, thank you so much, Sandra. Appreciate that comment. Before you make decision for your children, starting from the primary education, starting from their secondary school. It just I was in my office yesterday, and one of my team members was trying to access a particular platform called Mural, which we use for training at Lenso. And it just was like, whoa, she understands how to use Mural, and she's only 9 years old. The goal for me is to expose our children. I have 2 teenagers, 12 and 14. They have international certification. My 9-year-old is certified by Google. The goal is, let's leverage data to help make informed decisions. Let's help our children build a career that is sustainable. I always say there are 11 career paths within the data analytics environment. You can become a data scientist, a machine learning professional, project manager that understands data, business analyst that understands data. You can do so much miracle. So imagine that our children, our teenage youth, are exposed to data. Africa will be changed forever, and there are jobs that they can do. The goal is in the next 5 years, my children should start earning money, even as low as they're age 16. So data is powerful. We need to leverage that mindset to change Africa. Data can transform how we educate our children, transform Africa, and transform Nigeria. Thank you so much, West Africa, MCT West Africa, for this opportunity for us to share our contributions as MCC. Thank you. Wonderful section, Eddie. Thank you so much. You appreciate it. Thank you.
Thank you very much, Mercy, Maxwell, Etiosa.
Yeah.
Can we have a thumbs up before we go? It is a camera. Your camera is off.
Where's your camera?
All right. Thank you.
Yeah.
Bye-bye.
Thank you. Bye.
So that was a very insightful one from Mercy and her team. Thank you, Eddie. Great session. Yes, it was a great session. So yeah, that was a wonderful session from Eddie, from Maxwell. Sorry, Maxwell, Mercy, and her team. And yeah, so much have been said already. Data, the future is data. A lot has happened over time. A lot data has been acquired over time, and we need those data to predict the future, to predict even the present, right? Um, Thank you once again, Maxwell. Thank you once again, Mercy. We are very time conscious, and we'll be moving to um, the next session. Oh yeah, so the next session starts by 12:40 p.m. and we'll be having Enk Bowman talk about what is new with Azure machine learning. But before we go into that session, let's have a 10-minute break. Thank you. I'll be right back. Welcome back from that very short break. We have Enk already in the studio. Enk is a cloud advocate at Microsoft, specializes in artificial intelligence and Azure, and he has a background in application development. He's currently part of the regional cloud advocate team in the Netherlands, and he loves to share his knowledge about topics such as DevOps, Azure, artificial intelligence, and he provides training courses and also speaks at conferences and events. Enk is going to be talking to us about what is new with Azure machine learning. I'm going to be adding Enk to the stream now. Hi.
Hey, hello. How are you doing today?
I'm doing very well. How do you do too?
I'm doing good. I'm doing good.
It's nice having you. Let's get straight into it.
It's nice to be here. I'm excited. I saw the previous session. That was a good discussion.
Yeah, it was. Nice to have you too, Hank. Let's get straight into the business.
Perfect.
Yeah, so I'll be in the backstage. Good luck.
Perfect. Okay, hello everyone and welcome to my session. What is new with Azure Machine Learning? Are you able to see put my slides on the screen? Yes, perfect. Thank you so much. So, hi everyone. My name is Henk. I'm a cloud advocate. I already had an introduction, so no need to do that a second time. But I'm based in the Netherlands. But today I'm streaming to you from London. So I have a Twitter, GitHub, and a blog. So Twitter, you can follow me to stay up to date about Microsoft technology, about Azure AI especially. On my GitHub, you can find a lot of demos, a lot of AI demos, obviously. And on my blog, you will find some more larger tutorials supporting that technology on my GitHub. So today, in this session, we have 30 minutes, and there is a lot of things you can do with Azure Machine Learning. So I will start with explaining what Azure Machine Learning is. Then we're going to quickly train a PyTorch classification model, convert that in an Azure Machine Learning pipeline, and deploy that to a managed endpoint. And then while we're doing it, I will touch on all the things that are actually new. So what is Azure Machine Learning? Azure Machine Learning is a set of cloud services that can be controlled with a Python SDK, the Azure CLI. And with the set of cloud services, I mean, when you deploy Azure Machine Learning, you get a lot of services, not just Azure Machine Learning service. You get blob storage, you get key vaults, you get an Azure Container Registry, application insights, and all these services combined make Azure Machine Learning. And that set of cloud services, which we can control, enables us to cover the whole data science process, from preparing our data, to training our models, to deploying our models actually in production. So I'm just going to do demos today. I don't have that much slides. So let's dive into the Azure Machine Learning interface and see what we get. I will zoom in a little bit, but it should be visible. And if it's not visible, please let me know. So this is Azure Machine Learning. So you go to the Azure portal, you deploy Azure Machine Learning, and then you can go to ml.azure.com, where you can actually manage and view your studio. So this is the Azure Machine Learning Studio with a capital S. On the left, you have all the items, and here you have a dashboard. So let's go through the items. So let's start with environment things, because you need like compute, storage, connections to your data. So under compute, you find all your different types of compute. There are 4 types you can have in Azure Machine Learning. The compute instances, this can be used to run your notebooks and work together on code. Compute clusters are there used to train your models. So I have 2 clusters. One is called Optimus Prime, one is Bumblebee. One consists of standard NC6 machines. These are machines that have a GPU that is needed for some training, but not all training needs a GPU. Because and then you can just create a cluster for standard D3 V2 machines. So let's check out what we all know about this cluster. There are 8 nodes currently up and running, so that means that I'm paying for 8 nodes. But you can edit your resource properties here, and then you can say, oh, I want a minimum of 0 nodes. And then it automatically scales down when there is nothing to do. But it adds some extra time to for your job to actually start. You see that this one has a GPU, a Tesla K80 in it, and that will really help us speed up the processing. Here we see all the nodes that are up and running and doing actually nothing. See what runs are being completed, and we can actually monitor them now to see how these machines are actually behaving. Do I actually need the GPU? Do I need the CPU and the GPUs? Or is it just a waste of money and I can use another type of machine? Really handy. Next, we have data stores. These data stores handle the kind of connection to your to the data. So you probably have a bunch of images or CSV files or other things you want to train on, and you can make the connection here. So later on in your code, you can use a reference workspace, blob store default. Get me that, and you don't have to use credentials in your code. From data that is on the data stores, you can create data sets. So we're going to use my Lego Simpsons data set. We can have a quick look at it by exploring it. And we see that we have some Simpson images here. There are a total of 10 classes with everyone 50 images. And we're going to use that to train a classification model on it that can classify between the different Simpsons. There is some handy help here to tell you how you can consume it in Python. And on the details, we see when it is created, how many files are in the data set, and what the size is. And this data set is located on one of these data stores. Under experiments, we keep track of our experiments. So every time we train a model, it is locked under an experiment, and we can see find all the logging there. Pipelines. We're going to dive into that a bit later, but here we can see all our completed pipelines. And the models, you can save the models when you're done. So when you train an artifact, you can save a model management. And when we finally publish and write software around our model, we can deploy it in an endpoint. And we're going to see that also. So that is in a very, very nutshell Azure machine learning, and they didn't even touch on automated machine learning and the visual designer. So this is the GitHub code space. So you can just go to GitHub, and if you have a subscription on GitHub, you can start up a code space and just start working. It runs Jupyter notebooks, like in the browser for you. And you have a terminal here, you have Conda, you have all your tools you actually need without having the hassle of having like all those things installed on your local machine. So I have a notebook, and we will go through that notebook, which will train that classification model in, it should be in like 6-7 minutes. We start with importing a lot of dependencies. So all the code you're seeing here is Python, because we're using the Python SDK. And to do that, you need to install the Azure ML SDK in your local environment. I've already done that, but you can just do pip install Azure ML.SDK, and it will install all the tools you need for it. So then I'm going to connect to my workspace. So I tell it the name, the resource group, the subscription ID it has to log in. And now I've already logged in, but first it will pop up with your authentication to Azure. If that is granted, then you can connect. So we're using the workspace Cybertron, the compute target Optimus Prime, our default data store, and we're going to log everything under the experiment Simpsons PyTorch. So we're not going to train the model on our local machine. We're going to do that remotely on our compute cluster. But before we do that, we need to access the data. So we saw the data set, Lego Simpsons version 3. And we can now simply say dataset get by name, Lego Simpsons version 3. And now I've already access to my data, and I can use that later on in my scripts. So this training actually has to run in an environment. And for me, because I'm using the PyTorch framework, I need to run it in an environment that has access to, let's say, PyTorch. So there are curated environments that you can just pick out of the shelf and use, but you can also create your own environments, your own containers where it is going to run. So I'm just going to use this curated environment for me because everything is easily installed and I don't have that much special things I need. Then I have my data, my environment, I have my compute cluster. So now I have to combine these things in a script run configuration. So it actually knows, Azure Machine Learning knows how to execute my training script. I tell it where it can find my training script, which script it has to execute, on which compute target, which environment, and which incoming arguments. So at the incoming arguments, I have my Simpsons dataset. And what this actually does is it mounts my dataset as a virtual directory in a Docker container that is running on my compute cluster. And I can parse in some variables, and I want to train it for like 10 rounds. So let's dive a little bit in the training script. So this is the training script that I'm going to use. I got it from the PyTorch website. It's a default example for transfer learning classification. So I just copy-pasted the script, added some references that I'm able to import incoming arguments, and that I'm able to connect to my run context. I left the script as it is, but I added some extra logging here. So I'm sending all the telemetry back to Azure Machine Learning. And because this is an array of floats, Azure Machine Learning will automatically understand that it has to create a graph for me from that. Finally, I save the artifacts in the outputs directory because this runs in a Docker container on my compute cluster. I need to save my model because it will just shut down the Docker container and then everything is gone. But if you save things in the outputs folder, it is copied back automatically to your experiment and to your run, and you can access it later. So never forget to do this. So let's start the script configuration. We will submit it to our cluster, and then we can use this widget to actually track what is going on. So let's go back to the presentation and see what would actually be going on. So I'm on my local computer. I'm in this Jupyter notebook or in Python code that said submit. That moment, it snapshotted my training folder, where my train.py is, and you can have all other types of stuff in that folder. I copied it over to the experiment. Then it created a Docker container that pulled out its curated environment, or it's creating its own container, deploys that to our compute target, mounts data stores to that running image, then launches my training script, and then starts sending out some telemetry back to the experiment. And then my Jupyter notebook has a widget that connects to my experiment, so I can view actually those log files and telemetry data in my notebook. So here we are seeing that one job is actually running. Last time it took a little bit longer. Today, normally it should be done within like a few minutes. So we will have time to see it completed. So this is one way that you can actually see it. So we can now also go to experiments here. We see that it was Simpsons PyTorch. And here we see that it is actually queued. I wouldn't know why it would still be queued because there were 8 nodes up and running. So we will have to bear with it. But this will start. So let's take a look at a little bit older run that I just did like a few minutes, like an hour ago. So what we see here is that is the result of the training. So I told you I did a run.log, and this is the result of that function. It will do it for you. So you see the training accuracy hopefully going up and your training loss going down. But you can follow this, like when this actually starts, you can follow it in real time. So you can also stop it if you see that your model is going nowhere. We don't have images, we don't have childhoods in here, but under outputs, we can find all the nice details, which you can review later. So this is a lot of warning, but still. So this is the output my script has generated. So I guess everything I say print in my script will end up here. But I can also find the system logs. They just updated it, so I have to look a little bit. So you can really debug if something is not going that well. But here in the output files are the most important things. Here is my model that my script has delivered, and R is the label file. So here we have the 10 Simpsons it is all about. Now hopefully this thing will actually start up. It is actually running, so that is a good sign. Let's see if that is actually true. It is running, so that is great. Starting to generate logs, but it is not setting any metrics yet. So we will just continue with presentation here. Here you see the logs coming in. So the next thing you want to do is actually, the first training round has completed. The next thing you want to do is register that output as a model. Here, these are the graphs I was talking about. So let's wait for this model to complete. It should be going fast because I have MCT Bootcamp, so we can tag our models. So what we here do is say, register a model from this current run. Name it Simpsons classification. You can find the artifacts in output. We used PyTorch. I think we used 1.10. We can give it a description and then we tag it. This has to go up to 9 and then it should be done and then we can register it. So what happens when we register it? We'll find our models all back here. And the cool thing is that we here have Simpsons PyTorch. From here, you can actually track back how your model is being created from the run ID. And from the run ID, you can go back to the actual data set. So this whole process now is traceable. So we are at run 9 and it is finalizing. And when it is finalized, yes. So now we can register the output of our model. And we actually find our model back here with our tag MCT Bootcamp. So now we can deploy this model to a container instance. So I'm running these cells because you never know how long it's going to take. So again, we need an environment, but now I want to have a custom environment because I just like to have it more custom. And the reason for that is that I just want to have 100% control of what is in my environment. I don't need anything extra, and I want to make it as small and fast as possible. So I'm creating my own environment. I'm pointing to the script that is actually going to do the scoring of my model, combine it with the environment in an inference config. Next, I'm creating a deployment configuration, telling stores 40 bytes of memory, and then I say model, deploy this using this configuration. Wait for it. So it is actually done it already in 26 seconds. So that's really fast. So now what we can do is we can send images, testing images to the endpoint. And here it will predict that it is Bart Simpson. So we can do the same thing here on the endpoints now. We have Simpsons classification. I think it is this one. Wait, no. It's the other one. Sorry, let me have a look how I actually named it. Simpsons classification test. Yeah, it's this one. You can test it. We can send the JSON to it also nicely from here with the testing image. See that it is Bart, Lisa, hopefully is with a capital. Then we can send Homer to it. And so it kind of works. So this is one way of doing it. This is really good for prototyping and checking if your model is actually working. So now we can actually go to pipelines. So pipelines you can configure, and this is one of the new things I want to show you today, is you can configure your jobs in YAML. So you don't want to do everything in Python and in Jupyter Notebooks. So when you're finished with your exploration phase, you can convert it to YAML files and then actually productionalize your workload. So I'm going to just run it, and then we're going to go through this. So I created a script run configuration and connected to compute. So basically in this YAML file, we all do the same thing. So I'm telling, use this compute, use this data store, use this training data set as input. But what I can do now is I can create separate jobs that all do a separate thing, and I can actually make reusable jobs. Sorry for that. So the first thing I'm going to do is train the model, exactly what we saw. Then the output, I'm going to parse to another step in the pipeline, and it will register it for me. Then convert to Onyx step, because I want to have my model also available in Onyx format. I can convert it to Onyx. And then the outputs, I'm going to parse to the register Onyx, and I will also register this Onyx model. So when you submit this job, you can use the Azure CLI to execute this job. It will appear in Azure Machine Learning. And here are all the other components. So this is the register job that just tells what to do, what inputs, what to execute. And here are the files that actually do it. Because the cool thing now is that we have like kind of the configuration how your training has to happen, separated from the actual scripts that will do the training for you. So really cool development, I think. That's machine learning is what it is doing. Under pipelines. So here we see it is running. I can click on it, and it is drawing this really nice graph for me. And you see that it's using the input data set, parsing it to this step. Then we have two simultaneous steps, registering the model and starting to convert it to Onyx, and then finally it will register. And here we have exactly the same details about those jobs as what we would have under experiments, because this is also an experiment. Now, you click here, you see it visualized. If you click on these jobs, we have the same output, same metrics as with a single job. So really useful if you want to go to production and make your tools like more stable. So the last thing I want to show you is how we can deploy it, because you saw me deploying it to an Azure container instance, and that is probably not really the not really the most productionalized thing you want in a high performance organization. So there's a few months ago we introduced online managed endpoints, and this is really cool because now you can create a managed endpoint. Let's say we call it Hank, and we can do deployments in those and in that endpoint, in that single endpoint, and start routing traffic to the different types of deployments. And those deployments can individually scale and load balance. So that's really cool. So now I have model 1 and model 2, like version 1 and version 2. I know version 1 is working, so around 90% of my traffic. I take 10% of my traffic and route it to model number 2, which I'm going to use like a different configuration for. So maybe I can choose now and see, it runs better with the GPU or without the GPU. And it can help you automatically scale, which is like also pretty awesome. So I've deployed the models that been delivered by the pipeline, the Onyx and the PyTorch model, in a different endpoint. We can actually see it here in the endpoint, Simpson's classification endpoint. See Onyx 2 and PyTorch version 1. We're going to round robin with 50-50. I didn't configure auto-scaling. I just have one instance up from a very cheap compute instance. We can test it here. You can test the individual deployments here. There is some monitoring here. We can see how it is, how many requests are coming in per minute here. I was actually testing it a few hours ago. We can see the difference in latency. So let's test it. On the test. So what I'm going to do is I'm going to post to this endpoint with this token, with the security token, this image of Homer. I'm going to send the request. It is now hitting endpoint with PyTorch 1 and a prediction of 93%. And then now, we're lucky, sometimes you have to click a lot. We hit the other endpoint, Onyx, with the model Onyx 2, and we see that it is a little bit less accurate. And it's actually predicting it even wrong. So I have some work to do to make these models better, but this really kind of clearly illustrates that it is hitting different models in the same endpoint. You see, BART, it is actually working well with PyTorch. And with Onyx, BART is working well. So some classes are working well, some classes are absolutely not working that good. So two new things. We have seen. We have seen that you can now configure your jobs using YAML, and that we have introduced online managed endpoint to really put your models into production. So I want to thank you all for joining and listening. And if you're interested in this code installation, you can go to github.com/henkie/Azure Machine Learning PyTorch VS Code, spin up a code space, clone a repository, and get this working. So back to you.
Thank you. I was muted. Thank you very much. Thank you very much. That was an insightful session. Let me run through the comments just to see if they're okay. And there are presently no comments. So and if there are comments, if comments come through after this session, we would definitely let you know. So please, I want you to, for every participant, every viewers, I want you to head on to the link you are seeing on the screen and evaluate this session. We want to know what you think about the session. We want to see how the session has impacted you. We want to hear words from you, right? Thank you very much, Hank. It is really very nice to have you around. Thank you very much.
Thank you for having me, and enjoy the rest of your day.
You too. Bye.
Bye.
So we'll be going straight into our next break, and after the break, we'll be coming back for another session on okay, so the title of the session is going to be Let's Code a Drone to Follow Physics. You all know what drones are, so we're going to code a drone. I am not going to be doing that. We have a speaker who's going to be doing that, and it's going to be syncing everything with Azure IoT. So let's go on a very short break, and we will be right back.
Louisa.
Hi, Bruno. Um, Hi, everyone. Welcome back from that very short break. Up next, we have Bruno. Bruno is on the call. So, Bruno works at Avanade. He's a Microsoft AI MVP. He has been an MVP for the past 14 years. You can actually see those awards decorated right behind him. So he has been an MVP for the past 14 years, and he's an active Microsoft technology community user and participant. He writes and speaks at local and international technology conferences. He'll be leading us through a session titled "Let's Code a Drone to Follow Faces, Syncing Everything with Azure IoT." So I would go ahead and introduce and bring Bruno on board. Hi, Bruno.
Hey, hello everyone. Can you hear me well? Audio is fine?
Yes, very well. So I was just telling Bruno in the chat that this is the second time that I would be hosting him, and I look forward for the third time.
Yes, this is going to be a fast session.
Yeah.
It's kind of short time, but I hope that you get a sense of what we can do with a small drone. This is a toy, but it's mostly about having fun and learn stuff. So whenever you want, we can start.
All right. So I'll add your slide to the stream.
Awesome. So there it's my screen. So let me start my slides. Super fast. And again, this is an old slide, and you just mentioned this is what we are going to do: drones, face detection, Azure IoT. I hope that we can make everything. And my name is Bruno Capuano. I live in Canada. You probably noticed the accent. I am not Canadian. I was born in Argentina, moved to Spain, now living in Canada. And I was working in Avanade. I was a Microsoft MVP, but I joined Microsoft 5 days ago. So I moved away from all of that, but still it's amazing. I still love doing these kind of things. That's why I'm here talking about this. And hey, you can find me, most of the question, best way to find me is on Twitter, at El Bruno, or in my blog. And today is going to be, this is kind of the couple of things that we are going to use. Mostly Python. I'm going to do all of the coding in Python. I will use OpenCV to do some stuff like face detection and more, and then talk a little about computer vision. And I am not going to talk about the communication protocols because we don't have time to do this. So first of all, big disclaimer, sorry about the bad jokes, the crappy animations, the bad demos or whatever. Feel free to use the code. I'm going to share everything at the end, but it's not really for production code. So with all of this, what I am going to talk about, what I am going to use. So we have this drone. This is a very not expensive drone. I mean, when we think about programming flying drones that have some capabilities to program, we usually talk about a couple of $1,000, which is a lot of money. This is one that you can get for $100 US dollar now in Black Friday or in this or in Cyber Monday, or I don't know. If you have time to check the prices, you can even get this drone for half of the price. And the nice things about the drone is that it's not a super powerful drone. I mean, it doesn't have hours of battery or whatever. You only have 10 minutes of flight time with the battery, but it's good enough to connect and to start to do things because the drone has two wireless antenna, so you can connect to the drone in wireless mode. It has a decent camera, 720p. It's kind of good enough, and then it's stabilized. It does a lot of things, and it's also good enough. It's small enough that you are not going to need a license in most of the places to fly this drone. So you connect this drone to your phone, and you can fly it. When I was introduced to this drone, and it was a friend a couple of months ago, last year, I'm sorry, I realized that in the videos of the drone promotion, there was some kids programming the drone using Scratch. Scratch is a block programming environment where you connect the blocks all together, and it really attracted me to say that, okay, if these kids are programming the drone and they say, hey, drone, take off, drone, make a flip, move to the right, move to the left, or whatever, then land, I say, okay, there's probably going to be an SDK somewhere there. There is no SDK for the drone. It's basically not available. But somewhere deep in the web, we can find this PDF that basically explains how we can create our own SDK, or how we can communicate and send information and read information for the drone. So basically, when we connect to the drone, we are going to have we have the chance to open 3 ports, UDP ports. UDP is a very, very tricky communication protocol. We can talk about this later if you want. But once we communicate to this port, we have 1 port to send commands. So the first command that we need to send is the string command. Then we say, take off, make a flip, move to the right, move to the left, do something. Then we have another port that we are going to use to read information from the drone. Like an example, the battery status, the altitude of the drone, the accelerometer values, and the third port is for the camera. So with all of this, I think I was thinking, okay, this is good enough to start to do something. And I am going to finish with the slides right after this one, because I want to also explain to you how I have this set up for doing this demo. So what I have here is my machine. I have a big machine connected via Ethernet cables to internet. So this is what I am using right now to talk with you, to share my screen. And then I have here I am going to connect to the drone using the Wi-Fi, using the wireless connection. But because this is a toy, it's going to get disconnected. It's going to get, it's not going to be a full, amazing experience. So you are going to see me from time to time connecting and connecting and connecting. So this is kind of a disclaimer. Sorry about the crappy demos. And in a live environment, I will love if I can fly, go there and make this in a big stage. We are probably going to make the drone fly. Now, right now, I'm not going to make the drone fly. I'm going to basically do the most boring demo ever, which is read the battery. But stay with me. This is going to be excited later. So that's it. No more slides. Let's go there and let's start to connect to the drone. So I am going to use Python. I am going to use, where I am. I am going to use, I have Python installed. I think it's 3.9. I know it's 3.9, so I'm going to create a new file. Let's do this. Demo.py. But I just shared with you that I need to connect to the drone. I need to start to do stuff with the drone. So this is the drone. As you can see, it's very small. It fits in my hands. It's not very powerful. It's great. When I turn on the drone, I will get a LED. You're not going to see the LED blinking, but it's going to start to be a Wi-Fi hotspot. So if I go here to my Wi-Fi, at any moment here, I am going to see that there it is. This one here, that's the drone. So I can use Windows to connect to the drone. I can say to Windows 11 or Windows 10 or whatever operating system you have how to connect to the drone. But because the drone doesn't give me access to internet, Windows is going to disconnect and try to switch to an internet better network. So what I am going to do, I know my IP with the drone, so I am going to ping the drone. Let me ping the drone. So I am pinging the drone. I'm not connected right now. And I am going to use a command here, which is going to allow me to connect to the drone. So the drone is turned on. And if I use this command, it's a very simple command, net sh wireless connect, and the name of the drone network, you can see here that I am connected right now. So this screen will be in the back all the time to see if I am connected or not to the drone. So let's go back to do some code. And remember, this is going to be turned on and off a lot of time during the demo. So hey, let's get ready to see what we can do. Let's code. I am a programmer. This is the part that I like. So what is the first things that we are going to do? Import 3. Let me turn off Copilot. I am going to use 3 main libraries. Socket, because I'm going to open a couple of sockets to work with the drone. Time, to do some timeout, to do some kind of controls when I am interacting with the drone, and also threading, because I'm going to open each socket in different threads. So once I have this, the next step will be something very simple, something like this. Like, hey, In order to receive data, I am going to have a while true. Remember, this is not the best way to code this, so this is going to run all the time. And using one socket that I'm going to define later, I am going to receive a set of data. And this is going to be using chunks of 1024 bytes per code. The same for the second one, and the second one is going to open another socket, the one with the state of the drone, with the info drone, and this is a big string with a lot of info, so I know, in example, that the battery value, once I process the array, is in the position 21. I am going to show you this later, but remember, I opened two sockets in eternal loop, and in the loop I am reading information from the sockets. Then what I have to do is write some code to send the command. And this is the way that I'm going to send the command to the drone. I am going to get a timestamp, so I can do some timeout validation. I'm going to send the command in this socket. Important, need to be UTF encoded. And then I am going to validate, basically these lines are going to validate if after 5 seconds I didn't get a response, I will return a false here. And then I have some kind of overloads in the bottom. This is not overload, this is Python. But basically I am reading here, converts everything to string, and try to figure out if I have a response or not. So three functions, two to read information for each one of the sockets, one to send commands to the drone, and now we can start to almost connect to the drone and start to interact with the drone. So I know the IP of the drone is going to be 192.168.10.1. I know the ports because I read the document, so I find out the UDP port that I need to open. So what I'm going to do here, super simple, I am going to create two sockets for these two ports. I'm going to open them. That's super simple. That's as complicated it is. And then what I need to do here, what I start to do is start to define this, how we're going to use this. So let me create two threads. Remember, I am going to open the sockets in different threads. I don't want to block the main application. And I am ready to write the app. So this is, we can see that the previous code is kind of the basic SDK. And this is what I am going to use to basically interact with the drone. So I am going to define a battery variable. I'm going to start the SDK. First command I need to do is send commands. Then I read the battery, and then I'm going to print the battery. So with all of this, let me save this file. Let me copy this file, the path of this file. I will open a new Windows terminal. As you can see, I am disconnected for the drone. And let's go here. And by the way, so let's take a look. So that's the file. I just created the file, 733. So that's the demo.py. And I am going to turn on the drone and connect again. So I turn on the drone, I connect again, and when the ping start to return values, I am going to run the demo.py. So let's put this one here and wait a couple of seconds. Oh, I didn't turn on the drone, sorry. Trick the connection. One more time, and it should be on at any second. There it is. So I will run my code. Remember, it's a super boring code. It's not going to do anything. It's just going to connect, and after 5 seconds, it's going to show me that the battery is only 7. It's, oh my God, I'm running out of battery. Okay, I need to charge the drone. I have extra batteries, but hey, I have 7% of battery here, which is what we want to do. But to show you that we are really using data here of the drone, I am going to increase the sleep time. And when I read the information in this list of the drone, I am going to print this. So I'm going to print the list of values. So this is charging, yes. So I have this up and running. I get disconnected again, yes. Let me connect again. And I am going to run the demo again. And when I am connected, you start to see here that I have info. This is all of the info reading for the drone. And if I start to move the drone, you are probably going to see also how this data is kind of moving, because one of the values that I have here is the accelerometer value, is the accelerator value. So this is sending, this is reading real-time data. This is what I have here in the back is real-time data. And if I take a look to the data, I will see that I have, in example, pitch, roll, and yaw, which is basically the 3 axes of the drone. I have also the vector of movement here. I have, let me show you another information here. I have the temperature, low and high of the drone, the time of flight. I have the battery and the barometer here at the end. And I have also the important ones, which are the accelerometer. So I have here, it has an accelerometer embedded. So if I start to fly and move the drone, I will have the accelerometer values with the 3 axes, X, Y, and Z. So it's super simple to write these lines of code for the drone. And the only thing that I need to do, and let me see why this is not charging. And the only thing that I need to do, it's basically use these lines and connect and read the telemetry. But the idea is to use the camera. So how do we use the camera? So let's create a new file, camera.py, and let's start to write some code here. So in order to use the camera, I am going to basically use the same lines of code that we have right now, with the main difference that I'm going to also use OpenCV. OpenCV is one of the most popular libraries for image processing that we have. It started 10, 15 years ago, I can remember, by Intel. It was mostly used in the C++ world. We have porting for C#, for Python. I am using this in Python, but I also did a lot of demos of using OpenCV in .NET, if you want, with C#. And I am going to use OpenCV because what I really like about OpenCV is that it will allow us to connect to the drone and open a camera feed with almost no code. So if I start to write the connection of the drone, you can see here that this is very similar of what I just write. I'm going to send the command control, but in order to access the camera, I need to send a command, which is stream on. So the drone is going to start to stream the camera feed. Once I have this, I can start the camera. And this is the important part. I have here, this is the only thing that I'm going to need to access to the camera. So I'm going to have a direction. I know my IP, and I know the port that the camera is going to be open, 11111, so 11,111. And then I'm going to create an object, which is a video capture. And the video capture will allow me to access to the camera and get frames from the camera. So I can do a loop accessing the frame, and every frame is going to be the latest frame available from the camera. But the cool thing about this is that if I want to open a local camera, instead of using this, if I use the 0, it's going to open the camera from my machine. And if I have 2 or more cameras, it's going to open the index 0, the index 1. If I have a public HTTP camera or RSTP camera, I can also add here, and OpenCV is going to do all of the magic for us. So I am going to connect to the camera and get this video capture, and after this, I can start to basically display the camera from the drone. And again, here, what we have is an eternal loop. Don't do this. I see that we have here in the bottom the label that is an eternal loop. Don't do this. And I am going to have a counter here just to count the stuff. I'm going to use the battery kind of a pin to see what I am doing. And this is the line, the important line. I am going to use the reader to access the frame. I'm going to resize the frame so we can see it here. Remember, it's not a big frame, but I am going to make it a little smaller, and then I'm going to show it the frame. In OpenCV has a Windows viewer, which is called EM show, internal window show, and I'm going to use this image, and then I am going to wait. You can see this. Let me scroll here. I'm going to wait. If I press the letter Q, I'm going to stop the terminal loop. So that's basically it. Super simple. Oh. And the last line that I need to do, I need to send the command basically saying stop the streaming. I don't want to stream anymore. So that's it. That's what we need to do. And let's run this. Again, drone is disconnected. Let me turn on the drone. And when I have my IP returning, I am going to run this. If I take a look at the files here, let me move this one here. I have my camera file here. So while it's connecting, I am going to do the camera.py. Let me go here and start the connection. There it is. So I will run the camera file. It will connect to the drone, do everything that we already seen, and is going to open the camera drone in a new file. So what you see there, this is the drone, and this is my set. This is my office. You can see here I have a green screen in the back. This is not my real office. This is a virtual one. But hey, I am connecting here, and this is the live camera feed. So with this, I can start to do this. I can start to do a lot of amazing stuff here because I already have the camera. I already have the feed connected to the camera. So I can start to, in example, I can start to pick up each one of the frames and start to do some analysis. So if I want to do face detection, I can create a really, really quick file doing this. So let's do face common code, everything that we already done, everything that we already seen, and I am going to use a file that is available in the OpenCV, which is called the hair cascade to detect faces. So I'm going to do this, and then let's do display the faces, and that's basically it. So basically the idea here is that I am going to do the same code, but when I have here the frame that I get from the camera, I am going to use a file which is created with use a technique which is called the hair cascade to detect faces. And if I detect the face, I'm going to show the face, the face with the rectangle in the window, and that is going to be the face detected. And it's super simple. The only thing that I need to do, let me change the window name so you can see it here. Let's do MCT West Africa. The only thing that I need to do is add this file. So let me copy this file. I need this file in the folder. So there it is. And let's take a look here to the files. So this is the file that I have available here. As you can see, I have the file here. Need to connect one more time and show the faces. Let's connect this. And not this, and Python face.py. Once it's connected, I will run this. Okay, so it's connected. It will show the camera soon enough. There it is. So you can see there. And if I start to put this one here, somewhere there, you can see there that I have the face in the red frame kind of there, which is, hey, it's detecting faces. This technique, the one that I use, is not the best one. So I have also created some code here, and I'm going to share all the code using a more detection, in this one I use, basically instead of using a hair cascade, I am using another model, which is a deep learning model to do the detection. You can download the model. It's a 100 megabyte file, but it's the same lines of codes here. And once I am reading, let me go here. Once I read the frame from the camera, what I am going to do, I am going to detect the face using the deep learning network, and it's going to show the network. And from here, it basically we can do a lot of stuff. So let me show you how different is this one. So I'm still connected, yes. So let's do Python.
So we have a question. Sorry to cut in. We have a question from Mohammed. Can we get a copy of the code? Is that possible?
Yes, I am going to share everything as soon as we finish. Yes, for sure.
Then another question from John. Does this intelligence work with any drone?
No, I mean, this is the specification for this. For this drone, you probably need to figure out other drones and how they how they work. This is the camera using the deep neural network. This is the other network. Oh, I get disconnected. This is what's happening in real time. But no, this is specific to this drone. And I am going to share everything. The best way to share this, let me share it here right now. If I go to my GitHub, and maximize this. So if I go to my repo, I have it here. This is the URL that, let me paste here so you can share it in the main. So you can find all of the demos, all of the stuff that I just did here. You see that we have the camera, the demo, the machine learning, and a save from AI. And if you want to see the face detection demos, we can also use the ones. Oh, let me go here. This is Deck Online. Oh, I need to get more screen. Let me online.net show. This one. Oh, let me find one with the face demo. I am going to submit the today everything. Camera drone service. This is the IoT one. So in my repo, in the URL that I see, you can find anything. I am going to submit the code that I used today because it's kind of the last one. And just a quick recap. Also share the slides so you can have the contents. What we did today, and I know that we only have 1 more minute, is write SDK, access to some code, drone telemetry, access to the camera, and I missed the last part of Azure IoT. I know that we didn't have time, but I want to get this with the drone. And in these slides, you can find links. And again, I'm going to share this as soon as we finish. You can find links for the drone, the file with the PDF with the SDK. I write a lot about how you can do this. So you can check all of my blog posts about this, some custom vision information, and let me go back, and also another implementation of this. So if you want to take a look of how I did this, I write a lot of posts here of how you can do the step-by-step. You can see here is the intro, the Python samples, the hello world, the Wi-Fi, how you can do the Wi-Fi, the battery level, everything that I just did, explaining post by post, basically, so you can get here also the information. Let me share also the link here. So I don't know, we have another. Oh, I see another question that if you can use C#.
Can one use C#?
Yes, so I translate all of the demos to use C#. So in example, I can't remember when I did this, but if I search for myself, .NET docs show drone, there it is. So in this, not now, let me. So here is the same video, the same demos that I did today for the .NET docs show, but instead of using Python, I use C#, I use .NET. So you are going to see everything again here, but with the amazing. Instead of using Python, this is all C# and Visual Studio. And hey, that's basically it. As I said, you can find me in Twitter, in @Bruno. That's the best way to contact me if you want to have any question. Give me 10 minutes. I am going to share this to the latest code and the slides to Twitter also. And it's a pleasure to be here, man. You always rock these events. I really appreciate the invite. I wish that you have a great weekend. I see the agenda and all of the amazing speaker. This is great. And once again, super happy to be here. Thanks for inviting me.
Thank you very much, Bruno. That was an amazing session, as usual. And I hope we are able to connect again for the third time.
Yes, that's for sure. We're going to chat again. That's for sure. Okay.
All right. Thank you for now. Do have a very nice day. Bye.
Okay. Goodbye, everyone.
Yes, that was a nice one, a nice session from Bruno. Bruno used to work at Avened. He now works at Microsoft, and that's that's an exciting news. Thank you, John. Yeah, that was an interesting session. So we would be having our next session in 10 minutes time, and before that time, we'd go for a very short break, and yes, I hope to meet you again when I come back. Thank you.
Louisa. Louisa.
Hi, everyone. Welcome back from that very short break. Once again, I would like to remind you to complete the session evaluation for every session for you to stand a chance to win amazing prizes, including Microsoft Xbox. You know what that means. So head on to the link on your screen. I also dropped the link in the comment section a while ago. Head on to the link and fill in your feedback. Let us know how you feel about the program. Let us know what you've learned so far. Let us know how you think we can improve. So I'll be introducing David Okeyode on the call. I'll be adding into the stream right away. Hi,
Hello, hello, goodness, how you doing?
I'm very well.
Yeah, so first of all, let me just say thanks very much for the amazing job that you're doing. So it's been amazing, just coordinating and moderating the session. It's been just amazing what you've been doing. So thanks very much for doing that.
Thank you, sir.
Yeah. So unfortunately, due to some unforeseen issues, current speaker or the scheduled speaker is not able to make that. So instead, I'm going to be covering for the scheduled speaker. I'm going to be talking about something a bit different on that, but hopefully it's something that you're going to get useful information from. So I'm going to be talking about just an overview of just AI services and AI service components in Azure. This would be something like a beginner level for those that are just looking to really understand what this is about. This would be something that you're going to get some useful information from. So when we talk about just the aspects of AI and machine learning and data science, there are several related terms that people use when we talk about artificial intelligence. So it's very important for us to have clear definitions. When people talk about things like data science, so data science itself, it's a discipline that focuses on processing and analyzing data, right? So that's what this is about. So the discipline of data science is about processing and analyzing data, right? So, and this is really talking about just statistical techniques or mathematical techniques that can be used to uncover and to visualize relationship and patterns in data, right? So when you apply statistics to data, you can uncover certain patterns, right? So I heard some very interesting thing, right? So it is a very, very interesting point. Someone was talking about like vaccines, right, due to COVID that's going on. Someone was talking about the relationship and the connection between vaccines and people being able to live long in a society and how many children that people have. So because what they found was that actually if you have a society where the life expectancy is longer, where the survival rate is higher, right, what you find is that people tend to have less children, not more, right? So, and again, you may be thinking, how did they come up with that kind of pattern, relationship between if people are living longer, right? So sometimes you won't really find those relationships until you apply statistics to that, and you're going to go, there seems to be a trend here that's relating to this. Whenever that happens, this happens. So that is what data science is trying to uncover. So what are the relationships and what are the patterns in data is what that's going to be looking at. And then it's going to try to apply like some experimental model to explore those patterns. So it's going to apply experimental models, right? To say, let's build a model based on this pattern that we've identified. So that's the discipline of data science. Then we have people talking about machine learning, right? So when we talk about machine learning, so machine learning itself, it's a subset of data science, right? So machine learning deals with building, training, and validating predictive models. So that is what machine learning is about. It's about building, training, and validating predictive model. So what is that talking about, David, right? So what that's talking about is data scientists are preparing training data that they can use to train a model. To say, here is some data that we can feed into this model. And the model, of course, is based on an algorithm right? And there are different types of algorithms right there that would out there that we're not going to go into. Some of those are based on, there are tree-based methods. Some of them are based on neural networks, and there are different types of algorithms that are out there. But what the algorithm will look to do is that it will look to exploit the relationship between the features in the training data that's been supplied, and it's going to use that to predict values for unknown labels, right? So a very simple use case for that would be you're training a model to be able to identify a particular species of animal, right? So maybe you want to be able to have, maybe you're looking after wildlife management, and you want to be able to identify whenever an animal is seen in the wild. And you want to be able to capture images of animals using video cameras, and then pass that to a model that can identify and see, is this the animal that you're looking for or not? So you can have the model feed it with a lot of images of that animal, and so that the model gets intelligence to be able to predict if it's that animal or not, right? So that's sort of like the aspect of machine learning, is that we are building predictive models trained by data. And then we have the subject of artificial intelligence, which is referring to the capabilities of human intelligence. So that's what AI is about. AI is talking about how do we distill characteristics of human intelligence and make that into something that's repeatable, for something that's it's sort of like into software application, if you will, right? So that could be aspects of visualization, how to recognize objects. That could be aspects of speech and communication, right? Being able to, because as a human, if you're bilingual, you can hear speech in a language, and you can even translate it to somebody else in another language if you're bilingual, right? Or maybe you can hear speech in a language and you can extract certain meaning from that language, right? So maybe goodness says to me, David, I want you to get this information for me. And I can extract the intent from that statement that that goodness has made. Right, so we have all those aspects. So that's the aspect of artificial intelligence. So just be aware that there's these three main aspects that people talk about with data science, which really talks about just applying mathematical and statistical techniques to analyze data. Machine learning, which talks about training predictive models with data, and AI, which talks about really trying to replicate the characteristics of human in a software. That's what that's talking about. So when we're talking about this, when we talk about AI, we're talking about being able to build software that exhibits human-like capabilities like vision, text, speech, and also decision-making. And there's many aspects of this that we could get into, but in the interest of time, I'll just quickly move on. So when we talk about AI in Azure, or the AI landscape in Azure, there are multiple aspects that we could go into. So you have the aspect of creating AI. Many times when people hear AI, that's where they go to. They're like, how do we build models? And that is important. And I believe that we have Ank that has a session tomorrow that is going to be talking about what are the latest updates in machine learning in Azure, and it's going to be covering some other aspect of this. So if you have not yet planned for it, make sure that you attend the data and AI track tomorrow in that session, where you're going to get some more information about this aspect, right? So, but many people go straight to the aspect of creating AI, right? How do we go ahead and build these models? And that's very important, right? But then typically when we're talking about creating AI, again, typically you're talking about using services in Azure, like maybe Azure Machine Learning services, maybe with Databricks. And these are services that data scientists can use to ingest data. So you have data, you can ingest data into with those services. You can run experiments to explore the data and then to train predictive models. And then you can use frameworks like PyTorch and maybe TensorFlow to do that. And then once you've done that, you can package that model for deployment, maybe as a REST service, right? So you can, once you've trained that, you can make that available so that applications can then use that model or call that model and then to be able to use that. So that's the aspect of creating AI. But there are other aspects beyond creating AI. There are aspects of including AI. So this is really talking about the perspective of a developer. So you're a developer, you're not a data scientist, you just want to build intelligent applications. You're not really interested in creating predictive models and all of that stuff. You just want to be able to say, here is an image, identify this attribute for me. So the aspect of including AI, so we have services in Azure that you can use as part of that. You have services like cognitive services, which is a very, very, very popular service in this aspect. Services like Azure Bot Service, services like cognitive search that you can use for including AI in your applications. And then your applications built on top of that just make use of these services to provide those human-like capabilities that we talked about. So one of the services, when we're talking about including AI, is a service in Azure called Azure Cognitive Service. So what is Azure Cognitive Service? Azure Cognitive Service is about pre-packaged AI services. In other words, these are pre-built and pre-trained models. Pre-built, and in most cases, they are pre-trained. In some cases, you can train them with your own data. In many cases, they are already pre-trained with data that's been supplied by Microsoft so that you can just simply consume that. And it has capabilities in aspect of vision, in aspect of speech, in aspect of language, in aspect of decision, in aspect of search, right? And you have different APIs and services that you can use to integrate with these capabilities. And as a developer, you have SDKs that you can use to perform these integrations, right? So you have SDKs for .NET, for Java, for Python, for all these other languages that you can really use to integrate with vision, capabilities, speech, services, language, decision, and search. So if you want to start using cognitive services in Azure, 1 minute, I think I'm just, apologies. I think that, sorry about that. Apologies for that. Let me just quickly go to this. Oh, okay. Apologies. Yeah, sorry about that. I just got stopped. So let's go to this. So the first thing that we want to do is we want to provision a cognitive service resource. Is the first thing that you want to use. So if you're going to be able to use any of those capabilities, you have to go provision a cognitive service resource in Azure. So, and there are two options that you have here. You can create a what is called a multi-service resource, which it just means you have a single service where you have all these capabilities bundled together in that single service, right? So this will give you a single service. You have a single key, you have a single endpoint, and you can consume all these capabilities from that. It also has the advantage that you can consolidate billing from all these different services, right? Another thing that you can do is you can do just a single, you can do sort of like a single service resource. So single service resource is where you just have one capability that you want to use. So in this particular case, you have the capability for translation, capabilities for face recognition, and you're just going to create a single service for that. So, and in this particular case, you're breaking down the capabilities into individual services, and each individual service has its own unique key and its own endpoints that you can use to sort of reach that, right? It's important to also know that if you're using some services are going to require separate resources for model training and model prediction, because I mentioned earlier that even though majority of the services are pre-built and pre-trained, there are certain services in cognitive services that allows you to be able to train them with your own data. You feed your own data into that service to train it, and then it's going to train the model with your data, and then you now publish the trained model into an endpoint, into an API endpoint that your applications can call that endpoint and to be able to use those capabilities. So just be aware of that. So you see those when you're creating them, you see that in some cases they're going to say, do you want to create the service that's going to do both training and prediction? Or do you want to create a separate, in many cases, even if it selects both, what they're going to do is that they're going to create a separate resource for training, a separate resource for publishing, and the trained model into that. Oh, sorry, excuse me. Let me just look at the time now because I'm concerned that we'll run out of time. Goodness, how are we doing on time, sorry? How many more minutes do I have?
Yes, we still have about 9 minutes.
About 9 minutes, awesome. So I'll just quickly go ahead and I'll talk about some of that. So sorry about that. So if I go back to what I was talking about. So when you create the service, you're going to have endpoint keys and locations that you can use. So you have your application. Your application needs to be able to use these services, right? Your application needs to be able to call the endpoint of those services. So you're going to need that information once you create that service. The other thing is your application needs to authenticate itself, right? This is not unauthenticated access. You need to authenticate that you have permission to call that endpoint. So for that, you're going to need a subscription key. So let me go ahead and clean up the screen. So you're going to need a subscription key that you're going to use to authenticate. And then in some cases, location is also required for you to be able to provide. So how do you, as a developer, how do you interact or integrate with these services? Well, there are two main options. So you can either integrate with them by just using API calls. So you make an API call to the services, you make your request in JSON, you get your response back in JSON that tells you what you're asking for. So for example, I supply an image to the vision service of cognitive service, and I say, identify objects in this image. It gives me an HTTP response back, and it says, here are the different sections where I've identified object, here are the locations of the object in the image that you sent to me, and that's the information that you're looking for. So you can do that as a developer, but then it's going to be a bit more complicated. But now, because now you've got to do a lot of the formatting yourself, and essentially you just have more work to do if you're just using API calls. A better option would be if you're using any of these frameworks, you're using .NET, you're using Node, you're using JavaScript. There are SDKs that you can leverage, and you just need to add the packages to your application. Once you've added the packages to your application, then you'll be able to make calls to them. So it's going to be wrapped around like the different packages, and then you have APIs that you can use, and then that's going to make the call, and then you're going to get the response, and then you can easily sort out what you really want to. So in the interest of time, what I'm going to do is I'm going to quickly head over to the Azure portal. So I'm going to quit out of that, and I'm going to go create a resource. So if I go ahead and I create a cognitive services resource, and if I go ahead and I create that. So this is what you call the multi-service resource that I was talking about. You see that you get access to vision, language, search, and speech cognitive services with a single API key. So this may not always be good, especially talking from somebody from a security perspective, is that you need to acknowledge that certain of your data are going to be, especially because this is because of the search service, by the way. So because the search service is going to be used by Microsoft Bing, and that's why it's going to be asking you to say, just be aware that you're checking the box that maybe your data would be used as part of the search service. So I'll just go ahead and approve that. So I'll go ahead and put that in. I'll create a new resource group. I'll just call it a cognitive resource group. And I'll go ahead and put that in a location close. So let me put that in South Africa North. So let's put that in South Africa North. I'll call this DO Cognitive 01. And I'll select the standard pricing tier. So that's been used, probably being used by me. So I'll say 29. And okay, now that's available. So I'll go ahead and I'll acknowledge the terms and conditions. And you can also go read about Microsoft Responsible AI document. And in this case, so I won't be able to talk about why you need an identity for cognitive services, but that's for another conversation for another day. If I go ahead and I review that and I go ahead and I create that. So let's go ahead and do that. And I go ahead and I create that. So once I create that, So this is going to create the service, and then I'll show you just in case of just making just simple API calls to that service to use some of those capabilities. And again, this is something that anyone can really use, right? It's very, very straightforward and very, very simple to use. Once you have the service, you just need to identify the right calls that you need to make, and then you need to make that call. So, okay, so that is finished creating. So if I go to the resource that I just created, there are 3 pieces of information that I'll need. So I'll go ahead and bring that up on the screen. So 3 pieces of information that I need. Number 1 information that I need would be the endpoint. So if I go to here, I can get the endpoint there. And I'll go ahead and get that endpoint. The other information that I'll need is I'll need the keys. I can either click on here, I can go to keys and endpoints there, and I can get the keys that I want to use. So I can go ahead and I can copy the key. And in some cases, I'll need the location, so I'll need to specify the location. So I'll just go ahead and copy one of the keys, and I'll just make a note of the location also. So I'll just use the API in terms of making a call to that. So what I'm going to do is I'm going to make just an API call. So by the way, if you want to see how you can get started using that, the best way or the easiest way that I recommend is go to the overview section and go ahead and you can select the capability that you want to use, and then you have the documentation there that's going to take you through some quick starts that you can use to get started. So you go to quick start on something like computer vision. It's going to take you through that to the documentation, and you can see the example of if you want to make API calls, it's going to take you to the API documentation of that service, right? And then you can see the different calls that you can make, the different operations that you can use, and how you can use those operations. So this is a very robust document. So, but for now, I'll just make a simple one just to make the point that I was talking about. So in this particular case, I want to make a call to the service, and I want to make a call to the Vision service, to the Vision API. And I'm going to specify the location of my, the endpoint. So I'm going to go ahead and I'm going to add the endpoint there. And I'm going to call the Vision API version 2.0. I think it has a later version, and I'm specifying the features that I want to. So essentially what I'm going to be doing is I'm going to be sending this image to the service. So if I go ahead and I bring up the image that I'm going to be sending, I'm going to send it this image, and I'm going to ask it to essentially extract some features for me, like the category, the description of the image, information about landmarks that may be present in the image and all that. So if I go ahead and I copy that, and if I go to the Azure Cloud Shell, which has curl pre-installed, if you're using Bash, so I'll just go ahead and switch that to Bash, and I can go ahead and I can call that. So let's paste that, and if I run that, so I got a response back, but it's not well formatted. So what I can do is I can go ahead and clear the screen. So I'm going to run this again, and I'm going to format it using a tool called JQ. So JQ is a tool that you can use to format JSON requests if you're using just command line to call that. So I'll go ahead and run that again. This time around, I'll format the response using JQ, and it should properly render the JSON. And here you can see that it's categorizing the image that I sent, that I shared to it. It's categorizing that image as outdoor water, and it's about 99% confident of that. It has certain descriptions, so I can use this sort of information to do things like automatic tagging of images that have been submitted by users to a website, so that I can put that, let's say, in something like a Cosmos DB database, and use that as an index to search through certain images. So companies like Google use that for things like Google Photos, where they can do automatic tagging, and then you can search your pictures, and then it can bring up a picture that matches the tags. It gives information about the caption, the automatic caption. So it's giving it a caption of a large waterfall over a rocky cliff, and it's 91% confident of that. And that seems to be a bit, related. And it's giving just other information about that. So that's just some quick information about this. Oh, this one is weird. Where did they find the giraffe? Giraffe.
So we have a question here. Someone is asking Muhammad.
Yeah, so let's go for the question, sir. Oh, sorry, what's the question again?
How secure is this?
How secure is this? Good question. Well, you're talking to somebody who specializes in security. I could go in a lot of direction. Security is a shared responsibility. Security on the Microsoft side, right? It's usually well taken care of. I put that in quotes, right? So security on the Microsoft side is usually well taken care of. The communication between your endpoint and between your client and the endpoint goes over HTTPS, which is encrypted, using TLS, SSL, and TLS. So that's going over encrypted session. You have to keep your key secure, because if my key gets into somebody's hands, then they can just use my service for free to get this insight back. So there are multiple aspects. You have to look at responsibility from Microsoft's perspective, how they're doing, responsibility from your perspective, how you're doing with your responsibility in terms of how you're securing your keys and also your environment also.
We have another question from Mahmoud. I'm still both enthusiastic and scared at the same time about here. The question is, are there ways to give restrictions to the AI so they don't go beyond what its creator wants or take over the world? Oh, take over the world.
You've watched, I guess you probably watched some Terminator series and stuff like that. So that's a very, very good point. So Microsoft has like this old document on responsible AI, and AI is only what we make of it, right? So it depends on what you've made of it. So for example, you can have an AI service that's biased, right? Because you've trained it in such a way to be biased, right? You can have an AI service that's not without appropriate guardrails. There's a good example of that where I think it was Microsoft or some company that put a Twitter account out that was backed by AI, and within a few hours, it was saying the most racist stuff that you could hear of, because it was learning from people's interaction, and it was taking people's interaction and then essentially repeating that, and it was just saying all kinds of crazy stuff. So it's really all down to what's the struggle is that companies have to come together. Companies like Microsoft and other companies have to come together and working with each other and with the government to try to get things regulated. One of the things that I'm also as concerned as you, Mahmoud, is when somebody says, I have an AI, but this is intellectual property, I'm not going to release this. So in the AI world, there's this concept of promoting transparency, right? We need to be able to look at your algorithm. What exactly is it doing, right? It's not something that you keep eating. So there's this whole concept around open AI that I'm not able to get into. Connect with Goodness. Goodness knows a lot more about this than I do. So Goodness will hook you up and help you, get sorted.
All right. So I think we're actually far beyond time. We already have our next speaker in the studio. Do you have some final words to say before we end this session?
Not at all. I just want to say thank you very much, Goodness. You're doing an amazing job. Really, really appreciate it. I'm looking forward to the next session by Mr. Benga himself. The guy I hear is a very, very rich guy. The guy just came from California. The guy is just flying everywhere. So maybe look forward to some Bitcoin giveaway or something.
All right, that's good to be over. Thank you very much.
See you, everyone. Thanks.
All right. Okay, so our next session comes up now. Our next session is going to be led by Benga Oridupa. He is a data whisperer. He's gonna tell us what that means, anyways. He's passionate about information technology, data and solutions, and the data and the solutions that they bring to everyday problems. He craves for tech and data solutions that simplifies human efforts and produces honing accomplishment. He's going to be taking us through a topic titled uh, Introduction to Azure Storage Services. So I'm going to be adding him up to the stream now. Oh, okay. I'm very sorry. So I was sharing his screen instead of my screen. Okay. So I'm going to be adding him to the stream now, and he's going to be taking us on a session titled Introduction to Azure Storage Services. Hi, Mr. Benga.
Hi, can you hear me? Am I
Yes, I can
audible?
hear you quite well.
Awesome,
Can you hear me
awesome.
too?
Thank you. Don't mind Mr. David. He's trying to put me out there. I don't understand why. He's the big man here. uh,
It's
all
all
right.
it's all good, but there's no lie actually. Where's the lie?
Uh,
Show me. Where's the lie?
it's, oh. Thank you so much
It's
for
good.
the.
Let's jump right into the session.
All right. Can you see my screen?
Okay.
Am I sharing? Is it visible?
Yep.
Okay, awesome. Let me make it a full screen. All right. Can you see my screen right now?
Yes, I can see
All
your
right.
screen. Your screen is
All right,
fine. Right.
awesome, guys. Welcome, everybody. This is my session. My name is Gengar. As you can see, I'm a data tech enthusiast, or whisperer, or whatever you want to call it, because I love data and I love technology. But today, I won't be going deep into data science or AI, any data solutions, which is the areas I love. Data engineering, data integration, anything data. Um, no, any coding or analytics today, but I'll just be talking about storage, mainly storage on Azure. So let's go through my slides. So firstly, I want to talk about the history of data storage, right? Remember back in the day, we all started with using a lot of old methods to store information, right? Computers have stored data using a range of different technologies over the years. Originally, computer data was stored using punch cards, which represented computer data, right? And after that, we went into magnetic tape, which became the most popular method of storing data. And over time, we went to technologies that utilize tape cassette, floppy disk, and hard drives. I remember back in the day, I used to play a lot of soccer with floppy disk, right? A lot of games with FIFA and all that. Awesome, awesome. I miss those days, a lot of storage system back in the day. Floppy disks don't really take so much storage because they're really small, but they they did the work they needed to do back in the day. And another common form of storage usually is optimal storage. This comes in form of CDs, DVDs, and Blu-ray discs as well. And CDs does videos, music, any file storage as well, which is really awesome. Then we went to the flash drives, the SD cards, which we still use by today. We have flash drive with like 30 gig, 10 gig, 5 gig, depending on what you're using it for. You can use it for a lot of things, for storage, for application, and other stuff. And after that, we moved over to where we have the hard drive, the magnetic forms of storage due to much faster speed or longer life, right? We went to the bigger flash technologies, right? And after that, what happens next? We went into what we call the cloud storage. Now, today, cloud is one of the quickest forms of storage in the world right now, because storage is really, really cheaper right now with the cloud. And let's just look at it. Why? Cloud storage is not a physical storage device that you can just walk in the shop and buy, right? Basically, it's not like you can just go in there and buy it, right? You subscribe to a kind of a public service provider, right? Which utilizes kind of a data center that offers you solutions in terms of storage. So, which can exist in any location, right? Utilizing the internet technologies. So, let's go deeper to try and understand the cloud storage, right? Today, we understand how much data is being stored all over the world. Trust me, with your mobile phone, with how much stuff you do in your Twitter, on Facebook, you know Clubhouse, whatever you do, all these audio softwares, and even the internet, whatever you do, you're storing information every second. Now, this is a standard research I looked through online, and I saw in 2020, right, it was said that people created a 1.7 MB of data every second, and by 2022, you see 70% of global GDP will be undergone digitalization. You know what that means, right? Everybody's going digital. Now, in 2021, 68% of Instagram users view photos from brands. I mean, imagine how people that stayed on Instagram every day scrolling through photos and videos. Those data, I mean, they're stored every second. Now, by 2025, it says 200 plus zettabytes of data will be in the cloud around the globe. In 2020, users sent around 500,000 tweets per day. Can you just believe that? Now, by the end of 2020, 44 zettabytes will make up an entire digital universe. Now, every day we have about 306.4 billion emails sent, right? 500 million tweets are made. Can you just imagine how much data is being recorded? Now, if you don't have that massive storage to handle this kind of data, I mean, that's crazy. The world is growing. Data is growing every day. That's We are in the realm of big data, and everything is massive. It's crazy out there, and you just have to be prepared. Whatever application, systems, the solution we're building, you have to be ready to utilize that data to maintain all this process. And of course, data on its own has its own services that it offers to people, because people even utilize data as a way to make money by even selling information. So, it's one of those things Google is doing, with their search and everything with their Google Ads and all those stuff, which is amazing. And let's go straight to why we're here today. So, why Azure data storage, right? Why? Okay, let's look at the reasons why. Number one, we want to look at Microsoft Cloud Storage solution for modern data storage services. Um, One, the durable, highly available. Why? Redundancy ensures that your data is safe and events of transit hardware failures. You can also opt to replicate data across data centers or graphical regions for additional protection from local catastrophe or any natural disaster. That replicated in this way remains highly available in the event of any unexpected outage. So, in terms of any failure or one server going down and have an issue with the application, people are not able to retrieve information. That's why we have the highly availability, durability that Microsoft have provided for us. And the next point is secure. All data related to Azure storage is encrypted by the service. Azure storage provides you with a fine-grained control over who access your data. Of course, we want to secure our data. We don't want anybody to go in there anytime, you know. So that storage, that encryption service is there for you. And we have scalable, right? Okay, how is it scalable? Azure storage is designed to be massively scalable to meet the standard data storage and performance needs of today's application. So, anytime, there's sometimes where you have a lot of requests into your apps, or people require a lot in your services, and you know the application has to scale to be able to handle the amount of requests coming in. And sometimes you have to go down its own. So automatic scalability is there for you to utilize. Managed, right? Managed Azure handles hardware devices, updates, critical issues for you. You don't have to think about any manual updates or any patches in which Microsoft can handle for you. And we have accessibility, right? To be accessible. Data storage is accessible from anywhere in the world. So we have your HTTP or HTTPS protocol. We have the Microsoft provides client libraries for Azure storage in a variety of languages for .NET, Java, Python, and many more, right? We have your REST API. You can use your Azure PowerShell. You can use CLI to access it from anywhere in the world. That's amazing, guys. That's great. So here I'm going to talk about storage accounts. So the following table describes types of storage accounts recommended by Microsoft for most scenarios, and which can be used by our Azure Resource Manager for deployment, right? We can utilize that as a model. But yeah, I'm just want to list out those types of storages, right? And remember, before even if you access any services by Microsoft, you need to at least create a storage account. So, and there's different versions. We have the standard general purpose V2. We have the premium blocks 3. We have the premium file shares 3. We have the premium blocks page, right? And for each one, we have the data lake and the number one. We have the queues and table storage and Azure files. And we have the redundancy there at the third column. We talked about the LRS, the GRS, RAGRS. I'm going to talk in details on what the redundancy means and supported storage services. So this is just an highlight to show you the different categories of account you can create. And under those accounts, we have supported services for your storage, depending on what you want. So if you're going in the big data world where you utilize data lake storage, which is built on top of the blob storage by Microsoft, you can use that. If you're talking about the table storage, for Azure files, it depends on what you want, right? Talking about the NoSQL schemaless data storage, which is the Azure table, and Azure files for the share files as well. So let's go to the next slide. Azure Storage Platform includes the following data services. So Azure Blobs, right? What do you mean, right? This allows unstructured data to be stored and accessed at a massive scale in blobs. Also supports Azure Data Lake Gen 2, which I mentioned to you about big data, right? For enterprise big data analytics solutions. So if you're the big data guy, you like to write Spark, Hadoop, work on Python, Java for big data solutions. You have understanding of all this coding to help with data engineering, which is awesome. One of those stuff I love to do. Yeah, you can utilize that storage. And we talk about Azure files. It offers fully managed cloud file shares that you can access from anywhere in the industry standard using the SMB. That's what we call the server message block protocol. So you can mount your Azure file share from the cloud or on-premise deployment of Windows, Linux, or Mac OS. So any of the three operating systems support that. We have an Azure queues, right, which allows for asynchronous message queuing between applications. These applications then talk to each other. They can communicate asynchronously. And we have Azure tables that allow you to store structured NoSQL data in the cloud, providing a key attribute store with schemaless design, like I mentioned, bro, in NoSQL data storage. Now we have the Azure disk that allows data to be physically stored and accessed from an attached virtual disk, right? So that's our VMs. Here, I'm just going to look at the list of some endpoints that you can use to access those storage. So we have the block storage. So you have your HTTPS, and you can just have your storage account and .blob.core windows.net. You just give it access to the endpoint. So we have for data lake gen 2 for your big data analytics. We have Azure files. We have a queue storage, and we have a table storage as well. So they're all configured that way. Now, this is another interesting part that I like to tell people. You need to understand this process. Types of data redundancy for storage, right? We have the primary and the secondary. I will talk about the primary first. So Azure Storage offers two options how data is replicated in the primary region. Um, so locally, we have the locally redundant storage, which copies your data synchronously 3 times within a single physical location in the primary region. LRS is the least expensive replication option, but it is not recommended for applications requiring high availability or durability. Looking at the image on the right side at the top, that's what's showing you LRS. And we can see we are utilizing one data center, right? And we have our data replicated 3 times within that storage account. So it's just one account within one data center. That's why it's local. And if you look at the zone redundant storage, it says copies of your data synchronously across 3 Azure availability zones in the primary region. For applications requiring high availability, Microsoft recommends using ZRS in the primary region, also replicating to a secondary region. So if you look at the lower part on the right screen, we see our ZRS, right? So compared to the other one, you can notice we have 3 boxes in one rather than just one single box. So here we are utilizing availability zones, which have 3 data centers, right? So the application is regulated across multiple availability zones, which has an advantage, right? You are not just putting all your eggs in one location. So you have 3 data centers. Um, we have the secondary region, right? So Azure Storage offers 2 options here as well. We have the geo-redundant storage and we have the geo-zone redundant storage. The geo-redundant storage copies your data synchronously 3 times with a single physical location in the primary region using LRS. It then copies your data synchronously to a single physical location in the secondary region. Within the secondary region, your data is copied synchronously 3 times using LRS. So we already talked about LRS, right? And you can see that image at the right window at the top. We have the LRS, we have our files 3 times, right? In that storage account. And we talking about the geo, right? Geography, geolocation, basically. So now we have another data center existing in the secondary region. And basically it's just gonna replicate that data in another LRS in a different data center. So that's what that's doing for us right there in the diagram. And if you look at the second one, it says the GeoZone redundant storage copies your data synchronously across 3 Azure availability zones in the primary region using ZRS, right? It then copies your data synchronously to a single physical location in the secondary region. Within the secondary region, your data is copied asynchronously 3 times. All right, let me remove this, right? So if we look down there in the window, you can see, like we discussed earlier on the ZRS, right? This time around, we have a geo replication again into data center. So, and it's going to another secondary region, it's an LRS, right? With the single data center where we have all 3 files also copied. So this is what we call the read access GZRS, right? While the other one at the top is called the read access GRS. So RA means read access only, which gives user read access into that availability zone when anything goes wrong. So that's really important for us. So the factors that help determine Which redundancy option you should choose include: one, let's think about this. Number one, how your data is replicated in the primary region. Two, whether your data is replicated to a second region that is geographically distinct to the primary region to protect against regional disasters. Now, three, whether your application required to read access to replicated data in the secondary region if the primary region becomes unavailable for any reason. So if you think about these things, these are critical things you should think about when you're talking about the redundancy option that you need to choose for your application, your data. And here we talk about the story test. This is pretty much important. This actually determines and handles your cost management. And why did I say that? So this depends on how you're accessing the data you're storing. So we have the story tiers here, three categories: the auth, the cool, and the archive. The auth is an online tier optimized for storing data that is accessed or modified frequently. Now, the auth tier has the highest storage cost, but the lowest access cost. And why is that? So when you say auth, right, you frequently access this. So if you have a system or application that utilizes this data storage, right? The other time I showed an endpoint of access to a block storage somewhere, right, in the cloud. And if you have an application that calls this storage every time you use access an application, which is like frequently, then you must put that on the hot because it's a frequent access. Or maybe you're utilizing for AI solution, doing some image classification or running some regression on it, right? Then we have the cool tier, an online tier optimized for storing data that is infrequently accessed or modified. Data is cool. Tier should be stored for a minimum of 30 days. Remember, minimum of 30 days. Now, the cool tier has lower storage cost and higher cost compared to the hot tier, right? And that's because you don't access this frequently. You only use it for, once in a while, and it has that limited storage for 30 days. Now, when you talk about the archive tier, now that's an offline tier optimized for storing data that is rarely accessed, and that is flexible latency requirements on the order of hours, right? Data in the archive tier should be stored for a minimum of 180 days. So when you talk about archive, that means like it's something you don't frequently really use that much. It's like you keeping data, to be utilized for a future purpose, right? If you're just archiving them and it's not something you use frequently, or you know something you just put somewhere and then you can go there and grab that data later on to do some other additional processes, right? So it just depending how long you have to think about it. How am I using my data, right? How long does my data stay before I attempt to utilize it or use it in any form, right? That all depends on which category you select, because that will optimize your performance as well and determine how much you're spending. So that's pretty much important for your cost management. And we have the encryption part of the storage, right? So Microsoft OS 2, we have the encryption at rest, that Azure Storage Encryption protects and safeguards your data to meet your organizational security and compliance commitment. Azure Storage automatically encrypts all data prior to persistence to your storage account and decrypts it to prior to retrieval. Now, the encryption, description, and the key management process are transparent to users. Customers can also choose to manage their own keys using the Azure Key Vault. So if you're familiar with the Azure Key Vault, so that this pretty much makes sense to you as well. We're talking about the client-side encryption. The Azure Storage Client libraries provide methods for encrypting data for client library before sending across the wire and uh, scripting the response, right? So data encrypted via client-side encryption is also encrypted at the rest by Azure Storage, which I believe is awesome as well. Here we are looking at pricing samples. Here I'm just giving a snapshot of, you know, how it looks like. We are using a block storage here, and we're looking at the operation and data transfer, right? So if you look in your screen here, you can see the write operations, you see the read operations, you can see iterations, data retrieval. So it depends on what you're doing, right? If you're using a Premium, we have the auth, the cool, and the archive. So it's how much it costs you per each request. And I think that will make sense if you're trying to predict or calculate. So also we have something you can see from the website, which shows you a lot of calculations. We can go through that real quick. If you see, let me get the link out. So we have this pricing here. So this page is Microsoft Azure, where we can see our Azure pricing, right? So we have the products, we have pricing calculators, cost optimization, anything you want to do. So here, since we are talking about storage, you want to go down into our storage, and from here you can see what you want: storage account, you can view, and you can start checking out, what do you think you need. So this block storage general purpose for V2, this is LRS redundancy. You can just test out how many gig, how much does it cost me, see how much it costs you per month. Remember, this is not like a final say, right? It's just something to a budget to predict ahead of time to know how much you're going to be spending, what you need to look out for, how much is it going to cost you, so that you be ready before making any decisions. Remember, depending on choosing either alt or code or archive, it also affects your cost. And the storage, the location, see, we have block storage here. We have the standard version or premium. You go for the general purpose block storage or general purpose one. We have the auth here, and with cool on the archive. We have our redundancy here, the read only, GRS, LRS, all here. So you have to select which one you're looking for, and you look out here and make your selection, right? Which is awesome. So you can select 1 year reserve, 3 year reserve, you won't pay as you go. Different categories for you to maintain how much you want to be spending it right there in the cloud. So um, let's go back to our slide. So the next page here, we just talk about storage APIs, libraries, and tools. So we have our Azure Storage Data API and library references, which you can also find on the documentation out there on the website. For Azure Storage REST API, we have the .NET, the Java, the Node.js, Python, and other programming languages out there. And if you look at the API management and library as well, we have the REST API, we have the client library for .NET, and we have the storage services management REST API, and also for Azure Storage Data Movement API, right? So when you need to move data from one environment to the other, import and exportation using the REST API, you can use that. The data movement client library for .NET is also available for you. And talking about tools and utilities as well, we have our PowerShell command let for those that good with PowerShell scripting. We have the Azure CLI as well. We have the AZ copy command line tool, which is used in Azure, right? We have the Azure Storage Explorer, which is a free standalone Microsoft that enables you to work visually with Azure Storage on Windows, Linux, and Mac OS, right? And we have the Resource Manager template for Azure Storage. So we have all these tools and utilities for you to access the storage services. So remember, you have the PowerShell, the CLI, the command line, the Azure Storage Explorer, and the Resource Manager. And from movement, right, or data movement, we have your REST API and a client library for .NET. So let's go a little bit about here.
We have a question here.
Okay, what's the
So
question?
so we actually have a minute left for this session to end, but we have a question here from Mahmoud, and the question says, data on the cloud are physically located on a storage device somewhere. It is in the data center.
Hmm.
What will be the implication if the devices themselves get damaged? Will there be a way to retrieve the data? With my little knowledge, I actually know that there is something we call fault tolerance or disaster recovery thing, right?
Hmm.
But I'll
Yeah.
leave you to talk more on that.
Yeah, so like you said, right, these things happen, right? You might have an issue, data center have a problem, maybe something blew up or something got corrupted, or electrical issues, server going down. Like I mentioned, that's why you have the availability zone and replications, right? So if your data is replicated, so if you're doing the ILRS, which is local, and everything is one data center and everything has issue, then I mean you're completely out of it, right? But if you're utilizing a solution where your data is replicated into a different region in a different location, right? Even when your services are down in one location, you can easily have access to the same in a different location, and that's why that will help you. And with Microsoft, those things will work out for you, utilizing that approach for your storage. So yeah, I think that should answer your question. Any more questions?
No, I don't think there are any more questions. Would that be all from you?
Yeah, thank you. Thank you so much for the time. Thank you. I appreciate it.
Thank you very much, Mr. Benga. That was a very an insightful session from you, and we hope you heed our call the
Definitely,
next time we
definitely.
call you, because David has already said now that you are
No, David is joking.
that you are a boss. So
David
most
is the
likely you'll be
boss.
busy with mining bitcoins and whatever it is that
Ah,
you are. So I hope you'll not be too busy to pick our call when it's to call you.
no, it's all good. Thank you so
Thank you
much.
very
You
much.
did
That
a
will be all for
wonderful
now.
job.
Bye.
Thank you. Yeah, bye. Thank you.
Yes, so we have come to the end of the bootcamp today. It has been an